Hello, and welcome to Easy Drift Sleep. To support our quiet corner of calm, please consider liking this story and subscribing for future peaceful escapes. Imagine a world long ago when the vast dark ocean stretched out endlessly beneath a sky often cloaked in cloud or starless night. For millennia, humanity has looked to the sea, drawn by its mysteries, its bounty, and its formidable power. From the earliest coastal settlements, the need to navigate these waters, to find safe harbor, and to avoid treacherous shores became paramount. Before the compass, before detailed charts, before the intricate science of celestial navigation, mariners often relied on the most fundamental of guides, the land itself. But when the land disappeared into the gloom, or when storms raged, a different kind of guide was needed. A beacon, a signal, a promise of safety in the darkness. This is the story of those promises, those enduring sentinels that have stood against the might of the waves and the relentless wind, guiding ships and saving lives. This is the story of lighthouses, from their humble origins as simple bonfires on headlands to the sophisticated marvels of engineering and optics they became. We begin our journey in the ancient world at the very dawn of these guiding lights, where the concept of a permanent illuminated structure to aid navigation first took root. The earliest forms of lighthouses were not grand towers of stone, but rather practical, immediate solutions. Fishermen returning to shore might light a fire on a prominent hill to mark their village entrance. Coastal communities, eager to facilitate trade and protect their returning vessels, would maintain these fires, perhaps building a small stone cairn around them to shield them from the wind and make them more visible. These were the rudimentary beginnings, the instinctive human desire to illuminate the path home. As civilizations grew and maritime trade expanded, the need for more reliable and powerful navigational aids became pressing. The Mediterranean Sea, a cradle of ancient empires, was particularly active with shipping. Phoenicians, Greeks, and later the Romans plied its waters, carrying goods, soldiers, and ideas across vast distances. Shipwrecks were a constant threat, not only from storms, but from hidden reefs, shallow sandbars, and rocky coastlines. A permanent, highly visible marker was essential. The very concept of a lighthouse as we understand it today, a tall, purpose-built structure emitting a powerful light, finds its genesis in one of the most astonishing engineering feats of the ancient world. This was the Pharos of Alexandria, a name that has echoed through history, becoming synonymous with the structure itself. Indeed, the term Pharos is the Greek word for lighthouse, a testament to the enduring fame and influence of this singular edifice. Constructed on the island of Pharos, just off the coast of Alexandria in Egypt, this colossal structure was commissioned by Ptolemy I Soter, the first Hellenistic king of Egypt, and completed during the reign of his son, Ptolemy II Philadelphus, around the 3rd century BC. It was designed by the Greek architect Sostratus of Cnidus, and its scale was truly monumental. For centuries, it stood as one of the tallest man-made structures on Earth, a testament to the ambition and engineering prowess of its age. Estimates of its height vary, but many ancient accounts place it at over 100 meters, or more than 330 feet, making it comparable to a modern 30-story skyscraper. The Pharos was not a simple tower. It was a complex, multi-tiered structure built primarily of massive limestone blocks. It comprised 3 distinct sections. The lowest section was a broad, square base, housing the administrative offices, barracks for the lighthouse keepers, and storage for fuel. Above this, a tapering octagonal section rose, adorned with statues and intricate carvings. Finally, the uppermost section was cylindrical, and it was here, at its very peak, that the heart of the lighthouse resided, the lantern chamber. Ancient descriptions suggest that the Pharos was reputedly topped with a massive statue, possibly of Poseidon, the Greek god of the sea, or perhaps of Zeus Soter, Zeus the savior. This would have added to its imposing presence, serving not only as a navigational aid, but also as a powerful symbol of Egyptian might and Hellenistic culture. The light itself was produced by a large open fire, constantly fed with wood or charcoal. To amplify this light, ancient engineers employed ingenious methods. Stories tell of highly polished bronze shields or concave mirrors positioned behind the fire, designed to reflect and focus the flames, casting a beam far out to sea. Some accounts even suggest that these mirrors were so powerful they could be used to detect enemy ships at great distances, or even to burn them with concentrated sunlight. Though these claims are likely embellished, the Pharos of Alexandria was more than just a light. It was a landmark, a wonder of the world, guiding mariners into the bustling port of Alexandria, one of the most important trading centers of the ancient world. Its light was said to be visible from distances of up to 35 miles, an incredible feat for its time. It stood for over 1,500 years, enduring earthquakes and the ravages of time, a beacon of civilization until it was finally destroyed by a series of earthquakes in the 14th century. Its legacy, however, lives on, forever defining what a lighthouse could be. Following the example of the Pharos, and often inspired by its design, other ancient civilizations began to construct their own guiding lights. The Romans, in particular, were prolific lighthouse builders. As their empire expanded across Europe, North Africa, and the Middle East, they understood the critical importance of secure maritime routes for trade, communication, and military logistics. Roman lighthouses were erected at strategic points along their vast coastlines, marking harbors, river mouths, and dangerous headlands. These Roman structures, though perhaps not as grand as the Pharos, were nevertheless impressive feats of engineering. They often employed similar principles: a sturdy stone tower, an open fire at the top, and sometimes reflective surfaces to enhance the light. The Romans built lighthouses at places like Ostia, their main port near Rome, and at Leptis Magna, in present-day Libya. They even extended their reach to the distant reaches of their empire, constructing the first recorded lighthouse in Britain at Dover in the 1st century AD. The Roman lighthouse at Dover, known as the Roman Pharos, still stands today, albeit in a truncated form, within the grounds of Dover Castle. It is a remarkable testament to Roman engineering and their enduring influence. Originally, it was a tall octagonal tower built of tufa and flint, and would have guided ships through the treacherous waters of the English Channel, a vital link between Britannia and the rest of the Roman Empire. Its survival, even in part, allows us a tangible connection to these ancient guiding lights. The construction of these early lighthouses was a monumental task. They were often built on treacherous coastlines, exposed to the full fury of the elements, or on isolated islands, far from sources of labor and materials. Quarrying the stone, transporting it to the site, and then lifting it to great heights required immense organization, skill, and sheer physical effort. Tools were rudimentary, and the dangers were constant. Yet, the imperative of maritime safety drove these ambitious projects forward. The fuel for these ancient lights was primarily wood or coal. Maintaining a constant bright fire required a continuous supply of fuel and dedicated personnel to tend it. The flames would have been exposed to the wind and rain, making their reliability somewhat dependent on the weather. A strong gust could extinguish the fire, plunging mariners back into darkness. A heavy rainstorm could dampen the flames, reducing their visibility. These challenges underscored the need for further innovation. Over time, improvements were made to the design of the lantern chamber. Instead of completely open fires, some lighthouses began to enclose the flames within a protective structure, perhaps with openings to allow the light to escape. This offered some protection from the elements, making the light more consistent. However, the smoke from the fires could still obscure the light, and the heat generated was intense. The transition from open fires to enclosed lanterns marked a significant step forward in the safety and reliability of lighthouse illumination. It allowed for better control of the flame and protected it from the direct impact of wind and rain. Early lighthouse lenses were not the complex, multifaceted optics we associate with later lighthouses. Instead, they might have been simple glass panes, perhaps slightly curved, or even just polished metal reflectors, designed to gather and direct the light from the flame. These early systems were rudimentary compared to what would come, but they represented the cutting edge of technology for their time. The light from a lighthouse was traditionally amplified by intricate systems of mirrors or polished metal reflectors before the advent of more advanced lens technology. These early attempts at light amplification were crucial. A simple fire, even a large one, disperses its light in all directions. To make it visible from a distance, that light needed to be concentrated into a beam, however broad. Polished bronze, silver, or even highly reflective stone could serve this purpose, bouncing the light outwards towards the sea. As the Roman Empire declined and Europe entered the Middle Ages, the grand scale of lighthouse construction diminished somewhat. Many Roman lighthouses fell into disrepair or were repurposed. However, the need for guiding lights did not disappear. Coastal monasteries, castles, and port towns continued to maintain fires or simple beacons, often atop watchtowers or prominent cliffs. These were often maintained by local communities or religious orders, serving as local aids to navigation rather than the grand imperial projects of the past. The knowledge of constructing large, complex lighthouses was not entirely lost, but the resources and centralized authority required for such endeavors were often lacking. Yet, the principle remained: a light in the darkness, a signal of safety. Throughout this period, the technology of illumination remained largely unchanged. Open fires, fueled by wood or coal, with perhaps some basic reflectors. The challenges of maintaining these lights, especially in stormy weather, were immense. The keepers, or those tasked with tending the fires, faced arduous conditions, constantly battling the elements to keep the flames alive. The medieval period also saw the construction of some notable defensive towers that sometimes doubled as navigational aids. For example, the Tower of Hercules, near A Coruña in Spain, is an ancient Roman lighthouse that was continuously used and maintained, and later extensively renovated, demonstrating the enduring value of these structures. It is the oldest Roman lighthouse in use today, a remarkable testament to its original construction and subsequent care. As trade routes began to re-establish and expand in the late Middle Ages and early modern period, particularly with the rise of powerful maritime nations like Portugal, Spain, England, and the Netherlands, the demand for more reliable and powerful lighthouses resurfaced. The age of exploration, with its long oceanic voyages, further highlighted the dangers of uncharted waters and the critical need for coastal navigation. The design of lighthouses began to evolve slowly. Towers became more robust, built of stronger stone, often with thicker walls to withstand the relentless battering of waves and wind. The lantern rooms became more enclosed, using glass panes to protect the flame while still allowing the light to shine through. This was a crucial step, as it allowed for a more consistent and powerful light source, less susceptible to the whims of the weather. The fuel for the lights also began to diversify. In some regions, whale oil, a highly combustible and bright-burning substance, began to be used in lamps. These lamps, while still simple, offered a more controlled and consistent flame than an open fire. The use of oil lamps marked a significant improvement, providing a steadier light that was less prone to flickering or being extinguished by wind. However, these early oil lamps were still relatively dim by modern standards. The light they produced was not always powerful enough to penetrate dense fog or heavy rain over long distances. The challenge remained: how to produce a broader, more reliable, and more far-reaching light. This question would drive centuries of innovation, leading to the development of sophisticated optical systems that would transform the lighthouse from a simple beacon into a marvel of precision engineering. The early history of lighthouses, from the legendary pharaohs to the sturdy Roman towers and the simpler medieval beacons, tells a story of human ingenuity and perseverance. It is a narrative woven with the constant struggle against the forces of nature, the relentless pursuit of safety at sea, and the enduring human desire to light the way home. These ancient structures, often built by hand with rudimentary tools, laid the foundational principles for all that would follow. They established the critical role of a fixed, illuminated point in the vast shifting seascape. The challenges faced by these early builders and keepers were immense. Imagine the construction of the pharaohs, lifting enormous blocks of stone to such dizzying heights without modern cranes. Consider the constant vigil of a Roman keeper, tending a roaring fire through a gale, ensuring the flame did not die. These were not just buildings, they were monuments to human ambition and compassion, guiding souls through the perils of the deep. As we move forward from these ancient beginnings, the story of lighthouses becomes one of increasing sophistication, of engineering marvels that defied the ocean's fury, and of scientific breakthroughs in optics that transformed a flickering flame into a powerful, piercing beam. The stage was set by these early pioneers, who first dared to challenge the darkness with a steady, guiding light. The foundational knowledge, the understanding of the need, and the initial attempts at solving the problem of maritime navigation in the dark, all stemmed from these ancient endeavors. From the grand scale of the pharaohs to the more modest Roman beacons, the evolution was slow but steady. Each improvement, however small, contributed to a greater understanding of how to build and maintain these vital structures. The lessons learned from the collapse of some, the endurance of others, all fed into the collective knowledge that would eventually lead to the robust and powerful lighthouses of later eras. The very idea of a lighthouse, a solitary sentinel standing against the storm, was forged in these ancient times, a concept born of necessity and perfected over millennia. The world was slowly moving towards a future where the darkness of the sea would be consistently challenged, and the journey from ancient fires to modern lights was well underway. The journey from ancient fires to modern lights was indeed well underway, a slow and deliberate evolution shaped by the relentless forces of nature and the persistent ingenuity of humankind. The earliest lighthouses, if they could even be called that, were often little more than bonfires lit on prominent headlands, tended by local villagers or passing sailors who understood the desperate need for a guiding beacon. These rudimentary signals, while effective in their immediate purpose, lacked consistency and permanence. They were vulnerable to the elements, easily extinguished by sudden downpours or strong winds, and their fuel sources, typically wood or brush, were consumed rapidly, requiring constant replenishment. The light they cast was often diffuse, scattering into the night, rather than focusing into a powerful beam that could pierce through the thickest fog or the darkest storm. As maritime trade expanded, particularly across the Mediterranean Sea, the demand for more reliable navigational aids grew exponentially. The Greeks, Phoenicians, and Romans, all formidable seafarers, began to experiment with more sophisticated structures. The concept of a purpose-built tower designed to elevate the light source emerged as a practical solution. These early towers were often constructed of stone, providing a more stable and enduring platform than a simple pile of rocks. Inside, large fires were maintained, sometimes fueled by timber, at other times by pitch or oil, substances that could burn more intensely and for longer durations. The smoke from these fires, however, presented its own challenges, often obscuring the very light it was meant to project. One of the most famous, and certainly the most ambitious of these ancient structures, was the Lighthouse of Alexandria, often referred to as the Pharos of Alexandria. Its construction began around 280 BC during the reign of Ptolemy I Soter, and was completed under his son, Ptolemy II Philadelphus. This colossal edifice stood on the island of Pharos, guarding the entrance to Alexandria's bustling harbor in Egypt. Accounts vary, but it is widely believed to have been one of the tallest man-made structures in the world at the time, possibly reaching heights between 330 and 450 feet, or roughly 100 to 137 meters. Its sheer scale was a testament to the engineering prowess of the Hellenistic period. The architect credited with its design was Sostratus of Cnidus. The lighthouse was constructed in 3 distinct stages, each tapering as it rose. The lowest section was square, the middle octagonal, and the top cylindrical. At its apex, a massive fire burned continuously, fueled by wood that was hauled up by a sophisticated system of ramps and perhaps even internal elevators. Legend also suggests the use of a large polished bronze mirror, possibly concave, designed to magnify and project the light further out to sea. Such a mirror would have been an extraordinary feat of metallurgy and optics for its time, though its exact nature and efficacy remain subjects of historical debate. The Pharos served as a beacon for over 1,500 years, guiding countless ships safely into port. Its light was said to be visible from as far as 35 miles away, an astonishing range for an ancient light source. Beyond its practical function, it was also a symbol of Alexandria's power and prosperity, a marvel of the ancient world that inspired awe and wonder. Its destruction, gradual and tragic, began with a series of earthquakes in the 10th and 14th centuries, eventually reducing the magnificent tower to rubble. Its legacy, however, endured, so much so that the word Pharos itself became the etymological root for lighthouse in many Romance languages, such as French, phare, Italian, faro, and Spanish, faro. The fall of the Roman Empire and the subsequent decline in centralized authority across Europe led to a period where the construction and maintenance of large-scale public works, including lighthouses, largely ceased. The sophisticated engineering and administrative structures required to build and sustain such monumental projects were simply no longer in place. Maritime trade continued, of course, but often on a smaller, more localized scale, and the grand beacons of antiquity were replaced by simpler, less reliable methods of coastal navigation. Monasteries and religious orders sometimes maintained fires on prominent coastal points, acting out of charity and a sense of duty to seafarers. But these efforts were sporadic and lacked the systematic approach of earlier empires. During the medieval period, the concept of a lighthouse persisted, albeit in a more rudimentary form. Coastal communities, particularly those reliant on fishing or small-scale trade, would often light bonfires on cliffs or in purpose-built braziers. These fires served as warnings of dangerous shoals or as guides to safe harbor entrances. The technology, however, remained largely unchanged for centuries. The primary fuel was wood, sometimes coal, and the light was an open flame, susceptible to the winds of weather. There was little in the way of optical enhancement, and the range of visibility was limited. The reemergence of more organized lighthouse construction began in the late medieval and early modern periods, driven by the revival of long-distance maritime trade and the burgeoning colonial empires. As ships ventured further across oceans, carrying valuable cargoes and charting new territories, the need for reliable navigational aids became paramount once more. This era saw the construction of some of Europe's oldest surviving lighthouses, often built by local authorities, merchant guilds, or even private individuals with a vested interest in maritime safety. One notable example from this period is the Tower of Hercules in Spain, near the city of A Coruña. While its current structure dates primarily from the 18th century, it stands on Roman foundations and has served as a lighthouse since at least the 2nd century AD. It is the oldest Roman lighthouse still in use today, and is a remarkable testament to the enduring principles of its original design. The Romans built it to guide ships navigating the treacherous waters off the Galician coast, and its continuous function across millennia highlights the timeless necessity of such structures. Its original Roman name was Forum Brigantium, and it was extensively renovated in the 1780s, retaining much of its ancient form while incorporating modern lighting technology. Another significant development during this time was the use of coal as a fuel source. Coal fires, while producing a less intense light than some oils, burned hotter and for longer, requiring less frequent tending. They also produced a distinctive, often smoky plume that could be seen during the day, serving as an additional navigational marker. However, the smoke also posed a problem, often coating the inside of the lantern room and obscuring the light. The open flame also presented a constant fire hazard, a concern that would plague lighthouse keepers for centuries. The 17th and 18th centuries marked a pivotal period in lighthouse technology. The scientific revolution and the Age of Enlightenment brought new understandings of optics, engineering, and materials. The challenge was no longer just about building a tall tower and lighting a fire. It was about creating a light that was powerful, consistent, and recognizable. The concept of a fixed light versus a flashing or revolving light began to emerge, allowing mariners to distinguish one lighthouse from another, thereby pinpointing their exact location more accurately. One of the most ambitious and challenging lighthouse projects of this era was the construction of the Eddystone Lighthouse off the coast of Plymouth, England. The Eddystone rocks were a notorious hazard, responsible for numerous shipwrecks. The first attempt to build a lighthouse there was undertaken by Henry Winstanley in the late 17th century. His lighthouse, completed in 1699, was a marvel of its time, an eccentric and elaborate wooden structure, somewhat resembling a pagoda, adorned with cranes and external galleries. Winstanley was so confident in its strength that he reputedly wished to be inside it during the fiercest storm. Tragically, his wish was granted. In the Great Storm of 1703, both Winstanley and his lighthouse were swept away, leaving no trace. The destruction of Winstanley's lighthouse underscored the immense power of the sea and the need for structures of unparalleled resilience. A second lighthouse was built on Eddystone by John Rudyard, completed in 1709. This structure was also primarily made of wood, but it incorporated a more robust, conical design inspired by the shape of an oak tree. It stood for nearly 50 years, a testament to Rudyard's improved engineering, before succumbing to fire in 1755. The fire was reportedly caused by a spark from the coal-fueled lantern, highlighting the inherent dangers of the open flame. The third Eddystone Lighthouse, designed by the renowned civil engineer John Smeaton, was a true breakthrough. Completed in 1759, Smeaton's Eddystone was the first lighthouse to be built entirely of stone, using an innovative technique of dovetailed blocks. He meticulously cut each granite block to fit precisely into its neighbors, interlocking them like puzzle pieces, a method that gave the tower immense strength and stability against the pounding waves. Smeaton also pioneered the use of hydraulic lime, a type of cement that could set underwater, a crucial development for marine construction. His lighthouse stood for over 120 years, a testament to his engineering genius, before it was eventually dismantled due to erosion of the underlying rock foundation, not structural failure. Its top section was famously re-erected on Plymouth Hoe, where it remains a popular landmark. These early lighthouses, particularly those built in exposed locations, required constant vigilance. The job of a lighthouse keeper began to take shape during this period. These individuals, often solitary figures, were responsible for maintaining the light, ensuring the fires burned brightly, and keeping the lantern room clean. It was a demanding and often dangerous profession, requiring resilience, resourcefulness, and a profound sense of duty. Keepers would haul fuel, typically coal or wood, up winding staircases, sometimes hundreds of steps high. They would tend the flames, clear away soot, and ensure the glass panes of the lantern were spotless, allowing the light to penetrate the darkness unimpeded. The living conditions for keepers could be harsh. Many lighthouses were built on remote islands or isolated rock formations, cut off from the mainland for weeks or even months at a time by storms. Supplies had to be carefully rationed, and communication with the outside world was often limited. The isolation could be profound, leading to mental strain, but it also fostered a unique camaraderie among keepers who understood the singular nature of their calling. Their lives were dictated by the rhythm of the tides and the relentless cycle of day and night. Their primary purpose to ensure the light never failed. The development of more efficient light sources was another critical area of innovation. The open coal or wood fires, while powerful, were inefficient and produced a great deal of smoke. The 18th century saw the introduction of oil lamps, particularly those fueled by whale oil or colza oil, rapeseed oil. These lamps, enclosed within glass chimneys, offered a cleaner, more consistent flame. However, they were still relatively dim and required multiple wicks to achieve sufficient illumination. A significant leap forward came with the invention of the Argand lamp in 1782 by Aimé Argand, a Swiss physicist and chemist. This revolutionary lamp featured a tubular wick, allowing air to flow both inside and outside the flame, resulting in a much brighter, smoke-free light. The Argand lamp, often used in conjunction with a parabolic reflector, dramatically increased the intensity and reach of lighthouse beams. The parabolic reflector, a curved mirror, was designed to gather the light from the lamp and project it outwards in a concentrated parallel beam, rather than allowing it to scatter in all directions. This was a crucial step towards creating the powerful, focused beams that define modern lighthouses. The combination of the Argand lamp and parabolic reflectors transformed lighthouse technology. Suddenly, a single lamp could produce a light far more powerful than multiple open flames. This innovation laid the groundwork for the next major breakthrough in lighthouse optics, the Fresnel lens. A French physicist introduced his revolutionary stepped lens design in the early 19th century. Prior to Fresnel, lenses used in lighthouses were typically plano-convex, meaning they were flat on one side and curved on the other. These lenses were heavy, absorbed a significant amount of light, and were difficult to manufacture in large sizes. Fresnel's genius lay in understanding that the light-bending properties of a lens could be achieved by a series of concentric rings, or steps, rather than a single thick piece of glass. The Fresnel lens, first installed in the Cordouan Lighthouse in France in 1823, was a masterpiece of optical engineering. It consisted of a central plano-convex lens surrounded by a series of concentric prismatic rings, each precisely angled to refract and reflect light into a powerful, parallel beam. This design allowed for a much larger lens to be constructed, yet it was significantly lighter and more efficient than traditional lenses. It could capture almost 85% of the light emitted by the lamp, focusing it into a beam that could be seen for many miles. The Fresnel lens came in various orders, with the first-order lens being the largest and most powerful, used for major coastal lighthouses, and smaller orders used for harbor lights or less critical locations. A first-order Fresnel lens could be several meters tall and weigh several tons, a complex assembly of hand-ground glass prisms and brass framework. These lenses were so efficient that they multiplied the candle power of a lamp by several hundred times, effectively turning a modest light source into a piercing beam visible across vast stretches of ocean. The adoption of the Fresnel lens spread rapidly across the globe. It revolutionized maritime navigation, making coastlines safer and enabling ships to navigate more confidently in all weather conditions. The distinctive characteristics of lighthouses, their unique flash patterns, colors, and ranges, became standardized, allowing mariners to identify specific lights and determine their position with greater accuracy. The era of modern lighthouses, with their powerful, precisely engineered beams, had truly begun. As the 19th century progressed, further advancements in light sources continued. Kerosene, a refined petroleum product, began to replace whale oil and colza oil as the preferred fuel. Kerosene lamps burned even brighter and more consistently, and kerosene itself was more readily available and less expensive. The development of vaporized oil burners, where kerosene was heated and vaporized before combustion, further increased the intensity of the light, creating a brilliant, steady flame. The mechanism for rotating the lens also became more sophisticated. Early rotating lights often used clockwork mechanisms driven by falling weights. Keepers would have to wind these mechanisms periodically, often several times a night, to ensure the lens continued to turn. The precision of these mechanisms was crucial for maintaining the lighthouse's unique slash pattern, a vital identifier for mariners. The rhythmic sweep of the light across the dark sea became a comforting, familiar sight, a silent promise of safety. The construction of lighthouses also continued to evolve, drawing on the lessons learned from Smeaton's Eddystone and other pioneering projects. Engineers developed increasingly robust designs, using advanced masonry, concrete, and later steel. The challenges of building on exposed rock formations, submerged reefs, and shifting sands were met with innovative solutions, from caissons and diving bells to elaborate temporary structures that protected workmen from the relentless sea. The iconic red and white stripes, or solid colors of many lighthouses, were not merely decorative. They served as important day marks, allowing mariners to identify the lighthouse even when its light was not active. Each lighthouse was often painted with a unique pattern or color scheme, adding another layer of identification to its geographical location and optical characteristics. These visual cues, combined with navigational charts and the distinct flash patterns of the lights, created a comprehensive system of maritime guidance. The role of the lighthouse keeper, while still demanding, also saw changes. With more efficient lamps and rotating mechanisms, some of the physical labor was reduced, but the responsibility remained immense. Keepers were not just tenders of the light, they were also meteorologists, rescuers, and isolated guardians of the coast. They recorded weather observations, assisted shipwrecked sailors, and maintained the intricate machinery of the lighthouse. Their lives were a blend of routine maintenance and unpredictable emergencies, all undertaken with a deep understanding of the critical importance of their work. The late 19th and early 20th centuries brought the advent of electricity and incandescent light bulbs, further revolutionizing lighthouse illumination. Electric lights offered unparalleled brightness and reliability, eliminating the need for fuel storage and the constant tending of flames. The powerful carbon arc lamp was an early electric light source, followed by high-intensity incandescent bulbs specifically designed for lighthouse use. These electric lights, combined with the efficiency of the Fresnel lens, created beams of extraordinary power, visible for dozens of miles. The introduction of electricity also allowed for the automation of certain lighthouse functions, though full automation was still decades away. Fog signals, which had previously relied on bells, cannons, or explosive charges, could now be powered electrically, producing powerful blasts of sound that could penetrate dense fog. These foghorns, with their distinctive, often mournful cries, became another essential component of the lighthouse system, guiding ships when the light itself was obscured. The transition from oil lamps to electric lights was a gradual process, often dictated by the availability of electricity in remote locations. Many lighthouses, especially those far from power grids, continued to rely on oil or gas lamps well into the 20th century. However, the direction of progress was clear, toward greater power, greater reliability, and eventually, greater automation. The human element, the dedicated lighthouse keeper, remained at the heart of the system for a long time, their vigilance a crucial safeguard against the perils of the sea. The story of lighthouses is a continuous narrative of human endeavor against the elemental forces of nature. From the simple bonfires of ancient times to the towering optically engineered marvels of the modern era, each step in their evolution has been driven by the same fundamental need: to guide, to warn, and to protect. The quiet dedication of countless individuals, the relentless pursuit of scientific understanding, and the enduring power of engineering ingenuity have all contributed to these solitary sentinels, standing firm against the storm, their unwavering light a beacon of hope and safety across the vast, dark waters. The very essence of a lighthouse, its purpose to pierce the gloom and offer a core path, remains as profound today as it was when the first flickering flame was lit on a distant shore, a testament to humanity's deep-seated need for guidance through the unknown. Our journey into this sleepy history begins not with the familiar towering structures of today, but with the ancient world, where the concept of guiding mariners through treacherous waters first took root. Long before sophisticated lenses and powerful electric lamps, early civilizations recognized the vital necessity of marking dangerous coastlines and safe harbors. These initial efforts were often simple, yet profoundly effective, relying on the most basic elements available: fire and elevated ground. Mariners, navigating by the stars and the sun, found themselves vulnerable when darkness fell or storms obscured the celestial guides. The earliest forms of navigational aid were likely nothing more than bonfires lit on prominent headlands, maintained by local communities or watchmen. These fires, though crude, served as vital points of reference, distinguishing a safe approach from a hidden reef or a rocky shore. The ancient Egyptians, renowned for their architectural prowess and maritime trade along the Nile and the Mediterranean, were among the first to formalize these navigational signals. Their early structures, while not lighthouses in the modern sense, were precursors. They built tall towers or obelisks near river mouths and harbors, sometimes topped with braziers where fires could be kept burning. These structures served a dual purpose: monumental symbols of power and practical aids to navigation. The light from these fires, fueled by wood or pitch, would have been visible for several miles, a welcome sight to sailors returning for long voyages across the open sea. The sheer effort involved in maintaining these fires, hauling fuel up steep inclines or winding staircases, speaks volumes about the value placed on safe passage. The Minoan civilization, flourishing on the island of Crete, also developed sophisticated maritime practices. Their palaces and settlements, often located near the coast, likely utilized elevated positions to maintain signal fires. The intricate network of trade routes across the Aegean Sea would have demanded reliable navigational markers, especially during the stormy winter months. While direct archaeological evidence of dedicated lighthouse structures from this period is scarce, the prevalence of seafaring and the dangers inherent in coastal navigation strongly suggest the widespread use of signal fires. These early lights, flickering against the vast darkness, represented a nascent understanding of humanity's ability to impose order and safety upon the unpredictable natural world. As civilizations advanced, so too did the ambition to build more permanent and impressive navigational aids. The Greeks, with their extensive maritime trade and colonization across the Mediterranean, were pivotal in this evolution. They established numerous port cities and naval bases, each requiring reliable guidance for incoming vessels. While many Greek harbors had natural features that could be used as landmarks, the need for artificial light sources persisted. The famed Colossus of Rhodes, one of the 7 wonders of the ancient world, is sometimes speculated to have served as a lighthouse, though its primary function was a monumental statue of the sun god Helios. Standing over 100 feet tall at the entrance to the harbor, it would have been an unmistakable landmark. Some accounts suggest a fire may have been lit within a brazier held aloft by the statue, though this remains a subject of historical debate. Regardless, the very idea of such a colossal structure at a harbor entrance highlights the importance of visible markers for mariners. The true genesis of the lighthouse as a dedicated, purpose-built structure for guiding ships through light belongs to the Hellenistic period, specifically with the construction of the Lighthouse of Alexandria, also known as the Pharos of Alexandria. This monumental achievement, built on the island of Pharos in Egypt, near the city of Alexandria, stood as one of the most astonishing feats of ancient engineering. Commissioned by Ptolemy I Soter and completed during the reign of his son, Ptolemy II Philadelphus, around 280 BC, the Pharos was more than just a light tower. It was a symbol of power, knowledge, and humanity's mastery over the sea. Its design and construction were attributed to the architect Sostratus of Cnidus, whose name was famously inscribed on its base. The scale of the Pharos was immense, towering to an estimated height of between 330 and 450 feet, making it one of the tallest man-made structures in the world for many centuries, second only to the Great Pyramid of Giza. It was constructed from massive blocks of light-colored stone, likely limestone or marble, which would have gleamed brightly in the Egyptian sun. The structure was divided into 3 distinct sections. The lowest section was a broad, square base, housing the administrative offices, barracks for the keepers, and storage for fuel. Above this rose an octagonal middle section, tapering slightly as it ascended. Finally, the uppermost section was cylindrical, culminating in the lantern room where the light source was housed. The light source itself was a marvel of ancient technology. Accounts describe a massive bonfire, continuously burning, fueled by wood or pitch that was hoisted up the tower by a sophisticated system of ramps or perhaps even an internal elevator mechanism. The true innovation, however, lay in the use of a gigantic polished bronze mirror, positioned behind the fire. This mirror, carefully crafted and angled, would have concentrated the light, projecting it outwards across the sea. Ancient writers claimed its light could be seen from distances of up to 35 miles, an extraordinary range for its time. Imagine the sight for a weary sailor after weeks at sea to see that steady, brilliant beam piercing the darkness, guiding them safely into the bustling port of Alexandria. The very name of the island, Pharos, became the etymological root for the word lighthouse in many Romance languages, such as French, phare, Italian, faro, and Spanish, faro, a lasting testament to its iconic status. The Pharos was not merely a functional structure, it was also a masterpiece of decorative art. Statues adorned its various levels, and intricate carvings embellished its exterior. It served as a landmark during the day and a beacon at night, guiding ships to one of the ancient world's most important centers of trade and learning. For over 1,500 years, the Pharos stood sentinel, a testament to the ingenuity and perseverance of its builders. Its eventual demise was not due to poor construction or neglect, but to a series of powerful earthquakes that struck the region between the 10th and 14th centuries. The final collapse, around 1303, left only ruins, which were later incorporated into the citadel of Cape Bay, a medieval fortress built on the same site. Even in its ruins, the legend of the Pharos continued, inspiring generations of builders and mariners. Following the example of the Pharos, the Romans, with their vast empire and extensive maritime networks, also recognized the critical importance of lighthouses. They built numerous lighthouses across their domain, from the coasts of Britain to the shores of North Africa. Roman engineering prowess, celebrated for its durability and practicality, was well suited to lighthouse construction. They utilized materials like concrete, a revolutionary building material that allowed for stronger and more resilient structures. Roman lighthouses, while perhaps not as grand as the Pharos, were strategically placed and robustly built. One notable Roman lighthouse was the Tower of Hercules in present-day A Coruña, Spain. Originally built in the 1st century AD, this lighthouse has the remarkable distinction of being the oldest lighthouse in the world still in active use. Its original Roman structure, though modified and restored over the centuries, forms the core of the present-day tower. The Romans called it the Forum Brigantium, and it guided ships along the treacherous Atlantic coast. Its enduring presence speaks to the quality of Roman construction and the continuous need for its light. The Romans also built lighthouses at prominent ports, like Ostia, their main port near Rome, and at Dover, in Britain, where the remains of a Roman lighthouse still stand today, a testament to their far-reaching influence. These Roman lighthouses, like their ancient predecessors, relied on open fires for illumination. The challenges of maintaining these fires were significant. Fuel, often wood, had to be constantly supplied and hauled to the top of the tower. The flames were exposed to the elements, making them vulnerable to high winds and rain, which could diminish their visibility or even extinguish them. Smoke, a byproduct of the burning fuel, could also obscure the light, especially in calm conditions. Despite these limitations, the presence of a light, however imperfect, was infinitely preferable to complete darkness for mariners. The very act of seeing a light, knowing that land was near and guidance was available, provided immense psychological comfort, even if the light itself was not as powerful or consistent as modern beacons. The decline of the Roman Empire and the onset of the Middle Ages saw a general decrease in large-scale infrastructure projects, including the construction of new lighthouses. Maritime trade continued, but often on a smaller, more localized scale. Existing Roman lighthouses fell into disrepair or were repurposed. However, the fundamental need for navigational aids never disappeared. In many coastal communities, churches, monasteries, or castles built on prominent headlands would occasionally light fires in their towers to guide local fishermen or merchants. These were often informal arrangements, reliant on the goodwill of the local inhabitants rather than a centralized authority. During this period, the concept of a light often extended beyond literal fire. Prominent natural landmarks, like distinctive cliffs or islands, served as navigational aids. Man-made structures such as church steeples or watchtowers also functioned as daymarks, providing visual cues for sailors. The knowledge of local pilots, intimately familiar with the intricacies of their home waters, became paramount. These pilots, often hereditary, would guide ships through dangerous channels, relying on their deep understanding of tides, currents, and hidden hazards. Their expertise was a living form of navigational aid, passed down through generations. The resurgence of maritime trade in the late Middle Ages, particularly with the rise of powerful city-states in Italy like Venice and Genoa, and the Hanseatic League in Northern Europe, brought renewed attention to navigational safety. These trading powers depended heavily on sea routes for their prosperity, and the loss of ships due to poor navigation was a significant economic blow. Consequently, efforts to improve navigational aids began to emerge once more. In the 12th and 13th centuries, some of the first truly modern lighthouses began to appear, driven by the increasing volume of shipping. These structures, while still relying on open fires, were built with greater architectural sophistication and with the specific purpose of guiding ships. One of the earliest examples from this period is the Lantera of Genoa in Italy. While its current form dates largely from the 16th century, a lighthouse has stood on that site, guiding ships into Genoa's harbor since at least 1128. Its continuous operation, much like the Tower of Hercules, highlights the enduring importance of certain strategic locations for maritime navigation. The Lantera, at over 250 feet tall, was one of the tallest lighthouses in the world for centuries, a testament to Genoa's maritime power. The development of glass technology also played a crucial role in the evolution of lighthouses. While ancient lighthouses like the Pharos might have used polished metal mirrors, the widespread use of glass windows and eventually lenses would dramatically improve the efficiency of light projection. Early glass was often imperfect, but as manufacturing techniques improved, clearer and larger panes became available. These could be used to enclose the lantern room, protecting the fire from wind and rain, allowing for a more consistent and brighter flame. This seemingly simple innovation was a significant step forward, ensuring that the light would remain visible even in adverse weather conditions. The challenges of maintaining these early lights were immense. Lighthouse keepers, or wardens as they were often called, faced a demanding and often solitary existence. Their primary duty was to keep the fire burning brightly, day and night, regardless of the weather. This involved hauling heavy loads of fuel, wood, coal, or oil, up winding stairs, often hundreds of feet high. They had to constantly tend the fire, ensuring it did not diminish or go out. In stormy weather, the work became even more perilous, with high winds threatening to extinguish the flame, and driving rain making the ascent treacherous. The isolation of these early lighthouse stations, often on remote islands or exposed headlands added another layer of difficulty. Keepers were cut off from society for extended periods, relying on infrequent supply ships for food and other necessities. Despite these hardships, the role of the lighthouse keeper was one of immense responsibility and pride. Their vigilance directly impacted the lives of countless mariners and the safety of valuable cargo. The flickering light they maintained represented hope and safety to those at sea, a silent promise of guidance through the darkness. The early keepers developed ingenious methods to manage their fires, learning to identify the best types of fuel for a steady flame, and devising ways to protect it from the elements. Their lives were dictated by the rhythm of the tides and the demands of the light, a constant vigil against the perils of the sea. As Europe moved into the Renaissance and the age of exploration, maritime activity exploded. New trade routes were established, and ships ventured further across the oceans than ever before. This expansion necessitated a more systematic approach to coastal navigation. Nations began to recognize the strategic importance of lighthouses, not just for individual ports, but for entire coastlines and national security. This period saw the construction of more robust and numerous lighthouses, often funded by national governments or powerful trading companies. The 16th and 17th centuries brought further innovations. The use of coal as a fuel source became more common in some regions, offering a longer burning and often more intense flame than wood. However, coal fires produced a great deal of smoke, which could be problematic. Efforts were made to improve the design of lantern rooms, with better ventilation systems to clear the smoke and stronger glass to withstand the elements. The concept of a fixed light, a constant, unchanging beam, was the standard. However, mariners soon realized the value of distinguishing one light from another. If every lighthouse displayed the same steady glow, it would be difficult to identify which one a ship was approaching, especially on a coastline with multiple lighthouses. This recognition led to the early development of character for lighthouses. Initially, this might have involved simply varying the height of the light, or placing it on a distinctive natural feature. Later, more sophisticated methods emerged, such as the use of multiple lamps or the introduction of occulting mechanisms, devices that would periodically obscure the light for a brief moment, creating a distinctive pattern of flashes. These early attempts at characterization were rudimentary, but they laid the groundwork for the complex flashing sequences that would become a hallmark of modern lighthouses. The 18th century marked a period of significant technological advancement in lighthouse design. The demand for more powerful and reliable lights grew as maritime traffic continued to increase. The open coal or wood fires, while effective, had inherent limitations in terms of intensity and consistency. The search for a better light source became a priority. One of the most significant breakthroughs came with the development of oil lamps. Initially, simple wick lamps burning whale oil or vegetable oils were used. These provided a cleaner and more consistent flame than open fires, with less smoke. However, their intensity was still limited. The true revolution came with the invention of the argon lamp in 1782 by Aimé Argand, a Swiss chemist and physicist. The argon lamp featured a circular wick that allowed air to flow both inside and outside the flame, resulting in a much brighter, hotter, and more efficient combustion. This lamp, often equipped with a glass chimney to enhance the draft and protect the flame, produced a vastly superior light output compared to previous oil lamps. The adoption of the argon lamp in lighthouses was a game changer. It allowed for a much more powerful and steady beam, visible from greater distances. The light was also cleaner, reducing the problem of smoke obscuring the lantern. Lighthouse engineers quickly recognized its potential, and argon lamps became the standard for lighthouse illumination for many decades. The transition from open fires to enclosed, optimized oil lamps marked a pivotal moment in lighthouse history, moving from brute force illumination to a more refined and scientific approach. Alongside improvements in light sources, there was also a growing understanding of optics. The principle of using mirrors to reflect and concentrate light was known since antiquity, as evidenced by the pharaohs. However, the systematic application of lenses to focus and magnify light for navigational purposes was a more recent development. Early attempts involved simple parabolic mirrors which could project a beam in a specific direction. These mirrors, often made of polished metal, were somewhat effective but suffered from inefficiencies as some light would inevitably scatter. The true optical revolution for lighthouses arrived in the early 19th century with the invention of the Fresnel lens by Augustin Jean Fresnel, a French physicist. Fresnel's genius lay in his understanding of how to construct a lens that could capture and redirect nearly all the light emitted from a source into a powerful, concentrated beam, without the immense thickness and weight of a conventional lens of comparable power. He achieved this by dividing the lens into a series of concentric rings, or facets, each acting as a prism or a section of a lens, bending the light rays towards a common focal point. This design allowed for a much larger aperture and a shorter focal length, making the lens far more efficient and practical for lighthouses. The first Fresnel lens was installed in the Cordouan Lighthouse in France in 1823. The impact was immediate and profound. The light produced by a Fresnel lens was dramatically more powerful and visible than anything that had come before. It transformed lighthouse technology overnight, rendering previous optical systems obsolete. A first-order Fresnel lens, the largest type, could project a beam visible for dozens of miles, turning a relatively small oil lamp into a beacon of immense power. The light, instead of scattering in all directions, was meticulously gathered and focused, creating a narrow, intense beam that cut through the darkness and fog with unprecedented clarity. The Fresnel lens was not a single, monolithic piece of glass. Instead, it was a complex assembly of precisely ground glass prisms and lenses, held together by a brass framework. These lenses were categorized by order, with first order being the largest and most powerful, used for major seacoast lighthouses, and sixth order being the smallest, used for harbor lights or river navigation. Each order had specific dimensions and characteristics, designed to meet different navigational requirements. The manufacturing of these lenses was a highly skilled and labor-intensive process, requiring master glassmakers and optical engineers. The precision involved was extraordinary, as even slight imperfections could diminish the lens's effectiveness. The introduction of the Fresnel lens also facilitated the development of more sophisticated lighthouse characters. By rotating the lens assembly around the light source, a flashing or occulting light could be created. The rotation was initially driven by clockwork mechanisms, powered by falling weights. Lighthouse keepers would have to regularly wind these mechanisms, often several times a day, ensuring the lens continued its precise rotation. The weight, suspended down the central column of the lighthouse, would slowly descend, its energy transferred through gears to turn the massive lens assembly, which could weigh several tons. This intricate dance of gears and weights, silently turning in the lantern room, became a defining feature of many lighthouses. The combination of the argand lamp and the Fresnel lens ushered in the golden age of lighthouses. With these technologies, lighthouses could be built in increasingly challenging locations, on remote rocks and treacherous shoals, where they were most needed. The engineering challenges of building these rock lighthouses were immense. Structures like the Eddystone Lighthouse off the coast of Cornwall, England, or the Bell Rock Lighthouse off the coast of Scotland became legendary feats of engineering. These lighthouses had to withstand the full fury of the open ocean, enduring relentless waves and hurricane-force winds. Their construction often involved years of painstaking work, with crews only able to work during calm weather windows, battling the elements and the isolation. The Eddystone Lighthouse, in particular, has a storied history, with several iterations built on the same dangerous reef. The first, a wooden structure built by Henry Winstanley in the late 17th century, was swept away in a storm, taking Winstanley with it. The second, also wooden, built by John Rudyard, stood for decades before being destroyed by fire. It was John Smeaton's third Eddystone Lighthouse, built from interlocking granite blocks in the mid-18th century, that truly demonstrated the power of robust engineering. Smeaton, often considered the father of civil engineering, pioneered the use of hydraulic lime, a type of cement that could set underwater, a crucial innovation for marine construction. His design, with its broad base and tapering profile, became a model for future rock lighthouses. The Bell Rock Lighthouse, built by Robert Stephenson between 1807 and 1810, was another monumental achievement. Located on a submerged reef 11 miles off the coast of Scotland, it was considered one of the greatest engineering feats of its time. Stephenson, a brilliant engineer and the patriarch of a famous family of lighthouse builders, faced incredible challenges, including the remote location, the harsh weather, and the fact that the rock was only exposed for a few hours at low tide. He adapted Smeaton's interlocking stone design and employed a workforce of hundreds living on a temporary floating platform anchored near the rock. The lighthouse still stands today, a testament to his vision and the dedication of his crews. These rock lighthouses were not just engineering marvels, they were also symbols of humanity's determination to conquer the dangers of the sea. Their construction often involved immense personal sacrifice, with workers enduring harsh conditions and the constant threat of disaster. The stories of these early lighthouse builders and the keepers who maintained their lights are filled with tales of courage, resilience, and unwavering commitment to duty. They represent a period when the struggle against the raw power of nature was a daily reality, and the light from a lighthouse was often the only thing standing between a ship and certain destruction. As the 19th century progressed, the administration and maintenance of lighthouses became more organized. In many countries, dedicated lighthouse authorities were established, such as Trinity House in England, the United States Lighthouse Board, and the Northern Lighthouse Board in Scotland. These organizations were responsible for surveying coastlines, designing and constructing new lighthouses, maintaining existing ones, and training and employing lighthouse keepers. They standardized equipment, developed regulations, and ensured a consistent level of service across their networks. This professionalization of lighthouse management further enhanced maritime safety as lights became more reliable and their characteristics more consistent. The life of a lighthouse keeper, even with improved technology, remained one of isolation and routine. Their duties were meticulous, cleaning the lens, trimming the wicks of the argand lamps, winding the clockwork mechanism, polishing the brass, and keeping detailed logs of weather conditions and passing ships. The lens, a masterpiece of optical engineering, required constant care to ensure its pristine clarity. Dust, salt spray, and even insects could diminish its effectiveness, so keepers spent hours carefully cleaning and polishing each facet. The rhythmic sweep of the light across the dark waters was a direct result of their tireless efforts. The isolation could be profound, especially at offshore stations. Keepers lived in close quarters, often with only one or two companions, for months at a time. They developed unique routines and coping mechanisms to deal with the solitude. Some became avid readers. Others pursued hobbies like painting or carpentry. The arrival of a supply ship was a major event, bringing not only provisions, but also mail and news from the outside world. Despite the hardships, many keepers found a deep sense of purpose and satisfaction in their work, knowing that their vigilance saved lives. Their dedication was a quiet heroism, performed far from the public eye, yet vital to the safety of global commerce and travel. The transition from oil lamps to other forms of illumination began in the late 19th century. Kerosene, a refined petroleum product, gradually replaced whale oil and other animal or vegetable oils, offering a brighter and cheaper fuel. However, the ultimate leap forward came with the introduction of incandescent lamps, initially powered by gas and later by electricity. Gas-powered lights using acetylene or other combustible gases offered a more intense light than oil lamps and could be automated to some extent. The use of mantles, similar to those in gas lanterns, further boosted their brightness. The most transformative change, however, was the advent of electricity. Electric arc lamps and later incandescent light bulbs, powered by generators or connected to the national grid, offered an unprecedented level of brightness and reliability. The first electric lighthouse was Dungeness in England, lit in 1862. Electric lights eliminated the need for fuel delivery and significantly reduced the manual labor involved in maintaining the light source. Keepers no longer had to trim wicks or constantly replenish oil reservoirs. The light was simply switched on, and its intensity was far superior to any previous method. The electrification of lighthouses was a gradual process, extending well into the 20th century. Remote lighthouses, especially those on isolated rocks, often relied on their own generators or batteries for decades before being connected to a wider power grid. The shift to electric light also brought new possibilities for automating lighthouses. With electric motors replacing clockwork mechanisms for lens rotation, and photoelectric cells capable of turning the light on and off automatically at dusk and dawn, the need for a constant human presence began to diminish. This foreshadowed the eventual automation of most lighthouses, a process that would profoundly change the role of the lighthouse keeper. As we consider these advancements, from the simple bonfire to the sophisticated electric beacon, we see a continuous thread of human ingenuity driven by a fundamental need for guidance in all its forms. Has always been a symbol of hope and safety, a steadfast presence in a world of uncertainty. Its story is intertwined with the history of navigation, trade, and the relentless human endeavor to explore and master the seas. The rhythmic sweep of its light, whether from a flickering fire or a powerful electric lamp, has always carried the same message. A clear path lies ahead, and you are not alone in the vast, dark waters. This journey through the early history of lighthouses, from their ancient origins to the dawn of electric illumination, reveals a continuous evolution of human ingenuity and dedication. The structures themselves, the methods of illumination, and the lives of those who maintain them have all adapted to the ever-present challenges of the sea. Each innovation, from the simple bonfire to the complex Fresnel lens, represented a step forward in making maritime travel safer and more predictable. The silent vigil of these structures, standing firm against the elements, has provided comfort and direction for countless generations of mariners. As we continue our journey, we will delve deeper into the intricate workings of these guiding lights, exploring the mechanics of their beams, the lives of the keepers who dedicated themselves to their maintenance, and the storms they weathered. For now, let the steady rhythm of this unfolding history gently guide your thoughts, as the ancient lights once guided ships through the night. The stories held within these towering sentinels are as vast and deep as the oceans they watch over, offering a quiet calm as their light continues to shine across the ages. The quiet calm of a lighthouse's enduring light, a constant, unwavering presence, was maintained by a unique kind of dedication, a solitary vigilance that defined the lives of its keepers. These individuals, often known colloquially as wickies for their duty of trimming the lamp's wick, embodied a profound sense of responsibility. Their existence was intertwined with the rhythmic pulse of the light, a life lived in isolation, yet deeply connected to the safety of countless mariners. The daily routine of a lighthouse keeper was a meticulous ballet of precision and perseverance. Each morning, as the first hints of dawn painted the sky, the keeper would carefully extinguish the powerful lamp, drawing curtains or shutters to protect the delicate optical apparatus from the harsh glare of the sun. Then began the arduous task of cleaning. The lantern room, the very eye of the lighthouse, demanded immaculate attention. Every pane of glass, every polished brass surface, every intricate component of the lens system had to be spotless. Dust, salt spray, and condensation were relentless adversaries, threatening to diminish the light's intensity and clarity. The keeper would ascend the winding spiral staircase, sometimes hundreds of steps, to reach this sacred space, carrying cloths, polishes, and a quiet determination. The Fresnel lens, a marvel of 19th century engineering, required particular care. Its precisely ground prisms and rings, designed to capture and amplify the light, were susceptible to the slightest film of grime. Each facet had to gleam, reflecting and refracting the light with maximum efficiency. The keeper would gently wipe away any residue, ensuring that when night fell again, the light would pierce the darkness with its full intended power. This was not merely a chore, it was a ritual, a silent pact between the keeper and the sea. Beyond the lantern room, the machinery that propelled the light's rotation also demanded constant vigilance. Before the advent of electricity, these intricate systems were powered by clockwork mechanisms, often driven by falling weights. Imagine the gentle, persistent tick-tock of a colossal clock, its gears slowly turning, its weights steadily descending. The keeper's duty included winding these mechanisms, often multiple times throughout the night, to ensure the light continued its rhythmic sweep. This winding was a physical act, a testament to human effort sustaining the mechanical heart of the lighthouse. The smell of lamp oil, polished brass, and the ever-present tang of salt spray became the familiar scent of a keeper's life. The solitude of lighthouse keeping was a defining characteristic of the profession. For weeks, sometimes months, keepers lived in remote outposts, often miles from the nearest settlement. Their only companions might be the ceaseless roar of the ocean, the cry of seabirds, and the steady beat of the light itself. This profound isolation often fostered unique habits and hobbies. Many keepers found solace in reading, their small libraries becoming treasured havens. Others turned to writing, meticulously recording observations in logbooks, detailed accounts of weather, passing ships, and any unusual events. These logbooks became a vital historical record, chronicling not just the life of the lighthouse, but also the unfolding drama of the sea. Some keepers developed intricate crafts, carving, model building, or even painting, finding creative expression in their quiet hours. The lighthouse cat, or dog, was a common and cherished companion, offering comfort and sometimes practical pest control in these isolated dwellings. These animal friends were often the only living beings a keeper might interact with for extended periods, their presence a small warmth against the vastness of the ocean. The living arrangements for keepers varied greatly. In some of the earliest designs, the living quarters were built directly within the tower itself, spiraling upwards, providing shelter for the keeper and sometimes their family. This design meant constant proximity to the light, ensuring immediate attention to any malfunction. Other lighthouses, particularly those on more accessible shorelines, featured a separate keeper's dwelling, a small house or cottage nestled near the base of the tower, often surrounded by a small garden. This lighthouse reservation might include outbuildings for storage, a workshop, and perhaps a small patch of cultivated land, providing a degree of self-sufficiency. The watchroom or service room was often located directly below the lantern room, a space where keepers could stand vigil, observing the sea and monitoring the light's performance. From this vantage point, they would witness the full spectrum of maritime life, the peaceful passage of ships on calm nights, the terrifying fury of storms, and the constant, shifting moods of the ocean. The focal plane of a lighthouse, the precise height of its light above the water, was a critical calculation for mariners, and the keeper ensured this essential characteristic remained constant. The role of women in lighthouse keeping is a testament to their quiet strength and unwavering dedication. While often unofficial at first, many women stepped into the shoes of their husbands or fathers, taking on the demanding duties, sometimes after a tragedy or illness. Ida Lewis, an American lighthouse keeper at Lime Rock Lighthouse, became renowned for her numerous acts of heroism, saving many lives from her post. These women, like their male counterparts, demonstrated incredible resilience and commitment, proving that the light's guardianship transcended gender. Communication with the outside world was a challenge for isolated keepers. Signal flags, heliographs, devices that used mirrors to flash sunlight, and even carrier pigeons were employed in remote locations to send messages to shore. When supply boats arrived, they were a lifeline, bringing not only provisions and mail, but also a brief connection to the world beyond the lighthouse's lonely vigil. The relief keeper system was crucial, allowing regular keepers periodic breaks from their isolated posts, a chance to reconnect with family and society before returning to their solitary duty. The lighthouse service was often referred to as a silent service due to the isolated and solitary nature of the work. Yet, within this silence, a profound sense of purpose flourished. The keepers were not just maintaining a light, they were guardians of safety, silent sentinels whose unwavering commitment saved lives. Their stories are filled with quiet heroism, a dedication to duty that resonated with the very rhythm of the waves. The light itself, the very reason for the keeper's existence, possessed a language all its own. Each lighthouse had a distinct characteristic or signature, a unique flash pattern that allowed mariners to identify it in the darkness. This lighthouse effect was created by the rotation of the lens system, which briefly blocked or revealed the light, even if the light source itself was constant. A single flash, a group of flashes, a long occultation. These were the visual cues that spoke volumes to sailors navigating the treacherous waters. The range of a lighthouse, the maximum distance its light could be seen, was a crucial piece of information. This range was influenced by the light's intensity, measured in candela, and its height above the water. A powerful beam could cut through the darkest night, visible for tens of miles out to sea. a beacon of hope and reassurance. The rhythmic sweep of this light across the dark ocean was a constant, comforting presence for weary sailors, a silent promise of safe passage. Beyond the visual signals, lighthouses also employed sound to guide ships, particularly during periods of poor visibility. Foghorns, bells, and even cannons were used to pierce through the thickest mists. The sound of a foghorn, a deep, mournful bellow, became an iconic sound of the coast, a sonic warning that cut through the silence of the fog. Early fog bells were often operated by clockwork mechanisms, striking at regular intervals, their metallic clang echoing across the water. Later, more powerful signals like the diaphone produced a distinctive two-tone blast, often described as a grunt or bark, a sound that carried far through the dense, damp air. These sound signals were housed in separate fog signal houses near the lighthouse, containing the complex machinery required to produce such powerful blasts. Keepers were responsible for activating and maintaining these systems, ensuring that even when the light was obscured by fog, the lighthouse continued its vital role as a guide. The Light List, a comprehensive nautical publication, provided detailed information about all these navigational aids, including the characteristics of each lighthouse's light and fog signal. During daylight hours, when the light was extinguished, lighthouses still served as crucial landmarks. Their distinctive paint patterns or colors, known as day marks, allowed mariners to identify them from afar. Iconic red and white stripes, solid white towers, or unique structural designs were not merely aesthetic choices. They were essential navigational aids, helping ships fix their position on charts and avoid dangerous shoals or reefs. The light tower itself was designed to be a prominent feature of the coastline, a recognizable sentinel even without its brilliant beam. The constant threat of storms was an ever-present reality for lighthouse keepers. Waves, sometimes towering to incredible heights, would crash over the entire lighthouse, shaking its very foundations. During severe gales, keepers would often have to stay awake for days, battling the elements, ensuring the light remained lit and the mechanisms continued to function. The sound of the waves crashing against the base of the lighthouse became a constant, powerful symphony, a reminder of the sea's raw, untamed power. These storms brought not only danger, but also the potential for shipwrecks. Many tales of heroism are woven into the history of lighthouses, stories of keepers who, despite their isolation, risked their own lives to aid shipwrecked sailors. They provided shelter, warmth, and medical attention, often becoming the first responders in desperate situations. The constant maintenance required for a lighthouse included not only the daily cleaning, but also repairs from storm damage, repointing masonry, repainting, and tending to the complex machinery that could be affected by the violent impacts of wind and water. The keepers developed a deep, intuitive understanding of local weather patterns and sea conditions. They read the sky, felt the shift in the wind, and listened to the changing roar of the waves, becoming intimately attuned to the unpredictable nature of the ocean. Their meticulous logbooks often contained detailed weather reports, crucial information for meteorologists and mariners alike. Some lighthouses were even designed with storm windows to protect the delicate lantern room from the most extreme weather, a testament to the foresight of their builders. The lives of these keepers, their dedication to duty, and the steadfast presence of the lighthouses they maintained, created a tapestry of quiet heroism and unwavering vigilance. The light, the sound, the very structure of the lighthouse, all worked in concert to guide ships through the night, a constant, reassuring presence against the vast, dark expanse of the sea. The stories of these guiding lights and the people who kept them burning are as enduring as the structures themselves, their quiet strength a beacon through time. This unwavering dedication, this constant watch, ensured that the light continued to shine, a steadfast guardian against the perils of the deep, a silent promise of safe passage. The rhythmic pulse of the light, the steady presence of the tower, and the quiet devotion of its keeper combined to offer a profound sense of security, a gentle, guiding presence in the darkness. The rhythmic pulse of the light, the steady presence of the tower, and the quiet devotion of its keeper combined to offer a profound sense of security, a gentle, guiding presence in the darkness. This enduring legacy of light, passed down through generations of builders and keepers, continued to evolve, adapting to new technologies and new challenges, yet always maintaining its fundamental purpose. The very essence of a lighthouse, its steadfastness against the elements, its solitary vigil, became a powerful symbol not just for mariners, but for all who sought guidance and safety. The early lighthouses, often simple bonfires on headlands or rudimentary structures, gradually gave way to more sophisticated designs. The Romans, with their engineering prowess, built some of the earliest known purpose-built lighthouses, like the famous Pharos of Alexandria. This colossal structure, one of the 7 wonders of the ancient world, stood over 100 meters tall, its light said to be visible from 35 miles away. Constructed from massive blocks of stone, it featured a complex system of mirrors and a perpetually burning fire, tended by a dedicated staff. Its destruction, likely due to earthquakes, marked the end of an era of ancient maritime navigation, but its legend inspired future generations. After the fall of the Roman Empire, lighthouse construction waned in Europe for centuries. Maritime trade declined, and the knowledge of advanced engineering was largely lost. Navigation relied more on coastal landmarks, star charts, and sheer bravery. However, with the resurgence of trade during the medieval period, particularly in the Mediterranean and along the Atlantic coast, the need for navigational aids returned. Monasteries and religious orders sometimes maintained lights on prominent points, often simple lanterns or fires. These early efforts were sporadic and localized, lacking the systematic approach that would characterize later periods. The Renaissance brought a renewed interest in science, engineering, and exploration. As ships ventured further across oceans, the demand for reliable coastal markers grew. Spain, Portugal, and later England and the Netherlands, with their burgeoning maritime empires, began to invest in more permanent structures. These lighthouses were often built as part of fortifications or integrated into existing harbor defenses. They were still primarily fire-based, using wood or coal, which produced a smoky, often inconsistent light. The challenge was not just building a tall structure, but ensuring the fire remained lit, especially in stormy conditions, and that its light was powerful enough to penetrate fog and darkness. The 17th and 18th centuries saw significant advancements. The development of glass lenses and reflectors began to revolutionize lighthouse technology. Before this, light was often scattered inefficiently. Simple windows or open flames allowed much of the light to dissipate into the sky or towards the land, rather than out to sea. The introduction of parabolic reflectors, which could gather and project light in a more focused beam, marked a crucial step. These early reflectors were often made of polished metal, carefully shaped to maximize the light's intensity and range. One of the most significant figures in this period was Augustin Jean Fresnel, a French physicist who, in the early 19th century, invented the Fresnel lens. This revolutionary optical device transformed lighthouse illumination. Instead of a single heavy lens, Fresnel's design used a series of concentric rings of prisms and lenses, arranged to refract and reflect light into a powerful, parallel beam. This design allowed for a much larger aperture and a shorter focal length than traditional lenses, making the light far more efficient and visible from much greater distances. The Fresnel lens was a marvel of engineering and optics. It could capture nearly 80% of the light emitted by the lamp, focusing it into a narrow, intense beam that could be seen for many miles. Before Fresnel, a lighthouse might have required a large open flame, consuming vast quantities of fuel. With his lens, a smaller, more controlled light source could produce a far superior beam. The first Fresnel lens was installed in the Cordouan Lighthouse in France in 1823, immediately demonstrating its superior performance. This invention rapidly spread across the globe, becoming the standard for lighthouse optics for over a century. The adoption of the Fresnel lens coincided with the transition from open flames to more controlled light sources. Whale oil and later colza oil, a type of rapeseed oil, became common fuels. These oils burned more cleanly and consistently than wood or coal, providing a brighter, steadier flame. The wicks and burners also became more sophisticated, designed to maximize light output and minimize smoke. Keepers had to meticulously trim wicks, clean the glass, and replenish the oil, a constant vigil to maintain the precious light. The construction of lighthouses also became increasingly ambitious. As maritime traffic grew and shipping lanes became more crowded, the need for lights on dangerous offshore rocks and remote islands became paramount. These locations presented immense engineering challenges. Constructing a solid tower on an exposed rock, battered by relentless waves and gale-force winds, required innovative techniques and immense perseverance. The Eddystone Lighthouse off the coast of Plymouth, England, became a symbol of this struggle. The first Eddystone Lighthouse, built by Henry Winstanley in 1699, was an elaborate, ornate wooden structure, almost whimsical in its design. Winstanley, a self-taught engineer, was so confident in his creation that he wished to be in it during the fiercest storm. Tragically, in the Great Storm of 1703, his wish was granted, and the lighthouse, along with its builder and keepers, was swept away without a trace. This loss underscored the immense power of the sea and the need for even more robust construction. A second Eddystone lighthouse, known as Rudyard's Tower, was built of wood and stone by John Rudyard in 1709. It was taller and stronger than Winstanley's design, standing for nearly 50 years before being destroyed by fire. The third Eddystone, Smeaton's Tower, built by John Smeaton between 1755 and 1759, was a true engineering masterpiece. Smeaton, a civil engineer, pioneered the use of interlocking granite blocks, dovetailed together like a jigsaw puzzle, to create an incredibly strong, stable structure. He also developed a new type of hydraulic cement that could set underwater, crucial for building on the wave-swept rock. Smeaton's tower stood for over 120 years, a testament to his innovative design and meticulous construction. Its lower courses remain on the rock today, a silent monument to its resilience. The construction of these offshore lighthouses was an epic undertaking. Workers lived in temporary shelters on the rocks, often for months at a time, enduring harsh weather and isolation. Supplies were brought by boat, a perilous journey in itself. The work was slow, dangerous, and physically demanding. Each stone had to be precisely cut, transported, and then carefully fitted into place. The sound of hammers and chisels, the roar of the waves, and the cries of seabirds were the constant companions of these dedicated builders. The completion of such a lighthouse was a triumph of human ingenuity and perseverance over the raw power of nature. It represented a commitment to safety, a belief that no stretch of coastline, however treacherous, should remain unlit. These towers were not just functional structures, they were symbols of hope and progress, standing firm against the storm, their light a promise of safe passage. The keepers who tended these lights lived lives of extraordinary solitude and responsibility. Their duties were demanding and relentless. They had to maintain the lamp, ensuring it burned brightly and consistently. This involved cleaning the lens, trimming wicks, replenishing fuel, and winding the clockwork mechanisms that rotated the lens, creating the distinctive flash pattern of each lighthouse. Each light had a unique character, a specific sequence of flashes and eclipses that allowed mariners to identify their location. This character was crucial, especially in areas with multiple lighthouses. The keeper's day began before dawn, extinguishing the lamp and preparing it for the next night. Throughout the day, they would clean the lantern room, polish the brass, maintain the machinery, and perform general upkeep of the tower. In the evening, the lamp would be lit, and the vigil would begin. Through long, dark nights, the keeper would monitor the light, ensuring it never faltered. They were often alone or with one or two assistants, isolated from the mainland, for weeks or even months at a time. The isolation could be profound, especially for keepers in offshore lighthouses. They faced not only the physical dangers of storms and rough seas, but also the psychological challenges of solitude. Many keepers developed routines, hobbies, and a deep connection to their surroundings to cope with the isolation. They became keen observers of the weather, the sea, and the migratory patterns of birds. Their journals often contained detailed observations of these natural phenomena, providing valuable data for scientists and meteorologists. Supplies were delivered periodically, often by specially designed lighthouse tenders. These visits were eagerly anticipated, bringing not only food and fuel, but also news from the outside world, letters from family, and fresh reading material. The arrival of the tender was a brief but vital link to civilization, a moment of connection in an otherwise solitary existence. Despite the isolation, keepers were part of a larger community, the Lighthouse Service. In many countries, this was a government agency responsible for the construction, maintenance, and staffing of all navigational aids. These services provided a sense of camaraderie and shared purpose. Keepers often moved between different lighthouses throughout their careers, gaining experience and adapting to new challenges. The uniform, the regulations, and the shared commitment to maritime safety fostered a strong sense of identity. The life of a lighthouse keeper was not without its dangers. Storms could batter the tower, sending spray over the lantern room, making maintenance difficult and perilous. The sheer force of the waves could shake the entire structure, a constant reminder of the ocean's power. Rescues were sometimes necessary, both for shipwrecked mariners and for keepers themselves if they became ill or injured. The sea, while providing their purpose, was also their constant adversary. Fog was another significant challenge. The light, however powerful, could be obscured by dense fog, rendering it useless. To overcome this, fog signals were developed. Early fog signals were simple bells or cannons, fired periodically to warn ships. Later, more sophisticated mechanisms were invented, such as foghorns powered by steam or compressed air. These produced a deep, resonant sound that could travel for miles, cutting through the thickest fog. Like the light, each fog signal had a unique pattern, a specific sequence of blasts, allowing mariners to identify the station even when the light was invisible. The development of electricity further revolutionized lighthouse technology. Electric lamps, particularly incandescent bulbs and later arc lamps, provided a much brighter and more reliable light source than oil lamps. The transition to electricity also paved the way for automation. Early automation systems involved complex clockwork mechanisms and gas-powered lights that could operate for extended periods without human intervention. These systems were initially used in less critical locations or as backup systems. As technology advanced, the role of the lighthouse keeper began to change. The introduction of reliable electric power, sophisticated timing mechanisms, and remote monitoring capabilities meant that many lighthouses could operate without a constant human presence. The first fully automated lighthouses appeared in the late 19th and early 20th centuries. These early automated systems were often unreliable, requiring frequent maintenance and occasional human intervention. However, they marked the beginning of a gradual shift away from manned stations. The mid-20th century saw a gas sauce in automation. Solid-state electronics, improved power sources, and more robust mechanical systems made automation increasingly practical and cost-effective. The introduction of solar panels and long-life batteries allowed lighthouses in remote locations to become self-sufficient, eliminating the need for regular fuel deliveries. Remote monitoring systems could transmit data on the light's status, power levels, and any malfunctions directly to a central control station. This era of automation brought about the gradual phasing out of lighthouse keepers. While the technology offered significant advantages in terms of efficiency and safety, it also meant the end of a centuries-old profession. The last manned lighthouses in many countries were automated in the late 20th century, often with a sense of melancholy and nostalgia. The final departure of the keepers marked the end of an era, a transition from human vigilance to technological precision. Yet, even with automation, the lighthouses themselves remained. Their sturdy towers, built to withstand the harshest elements, continued to stand as silent sentinels. The Fresnel lenses, many still in place, continued to focus and project their powerful beams, now powered by electricity rather than oil. The rhythmic flash, the distinctive character of each light, persisted, a familiar reassurance to mariners navigating coastal waters. Today, lighthouses continue to serve as vital aids to navigation, though their role has evolved. Modern Global Positioning System, or GPS, and other electronic navigation systems provide mariners with highly accurate positioning data. However, lighthouses still offer a crucial visual reference, especially in coastal waters, during periods of electronic failure, or simply as a reassuring sight after a long voyage. They provide a tangible connection to the shoreline, a fixed point in a dynamic world. Many lighthouses have also found new life as historical landmarks, tourist attractions, and even unique accommodations. Their architectural beauty, their dramatic settings, and the rich history associated with them draw visitors from around the world. Museums dedicated to lighthouses preserve the stories of the keepers, the engineering marvels, and the maritime heritage they represent. These structures, once purely functional, have become cherished symbols of human endeavor and resilience. The quiet strength of the lighthouse, standing firm against the storm, its light piercing the darkness, continues to inspire. It is a testament to the enduring human need for guidance, for safety, and for a beacon of hope in uncertain times. The legacy of the ancient pharaohs, the ingenuity of Fresnel, the perseverance of Smeaton, and the quiet dedication of countless keepers all converge in these magnificent structures. The story of lighthouses is a story of constant adaptation, of technological progress, and of unwavering commitment. From simple fires on cliffs to complex automated systems, the fundamental purpose has remained the same: to guide, to warn, and to protect. Each flash of light carries with it centuries of history, a silent narrative of storms weathered, lives saved, and journeys completed. The gentle rotation of the lens, the steady sweep of the beam across the dark expanse of the sea, creates a hypnotic rhythm. It is a rhythm that speaks of constancy, of a reliable presence in a world of change. The light appears, holds for a moment, then vanishes, only to reappear again, a steady, reassuring pulse. This cyclical motion, this predictable pattern, offers a profound sense of peace. Imagine the quiet hum of the machinery within the lantern room, the soft glow of the electric lamp, the precise movement of the gears. The air might carry the faint scent of salt and the distant cry of a seabird. The waves might crash against the rocks below, a constant, soothing murmur. The wind might whisper around the tower, a gentle, unseen force. The light continues its silent work, a steadfast guardian against the perils of the deep, a silent promise of safe passage. The rhythmic pulse of the light, the steady presence of the tower, and the quiet devotion of its purpose combine to offer a profound sense of security, a gentle, guiding presence in the darkness, inviting a deep and peaceful rest. The rhythmic pulse of the light, the steady presence of the tower, and the quiet devotion of its purpose combine to offer a profound sense of security, a gentle, guiding presence in the darkness, inviting a deep and peaceful rest. As the centuries turned, the simple fires atop ancient structures evolved. The Roman Pharos, like the renowned Lighthouse of Alexandria, was a marvel of engineering for its time. But its illumination relied on large open fires. These fires, while visible, were often inefficient, consuming vast quantities of wood or coal. The smoke they produced could obscure the very light they were meant to cast, particularly in foggy or stormy conditions. Maintaining such a fire was a constant, arduous task, requiring a dedicated team to haul fuel up winding stairs and tend the flames through long, dark nights. The light itself was often unfocused, scattering its precious energy across the vast expanse of the sea, without the precision that would later become a hallmark of lighthouse technology. The medieval period saw a decline in the construction of grand lighthouses, as maritime trade experienced various shifts and disruptions. Many of the Roman structures fell into disrepair or were repurposed. However, the need for navigational aids never truly vanished. Coastal communities and monastic orders sometimes maintained beacons, often simple bonfires on headlands, to guide local fishermen and trading vessels. These were localized efforts, lacking the systematic approach and engineering sophistication of the earlier Roman era. The focus was often on practical, immediate needs rather than grand, enduring structures. The true resurgence of lighthouse building began in earnest during the Age of Exploration and the subsequent expansion of global trade routes. As ships grew larger and voyages became longer and more frequent, the demand for reliable navigational markers intensified. The risks of shipwreck were immense, and the loss of cargo and lives spurred innovation. This era saw the emergence of more robust and strategically placed lighthouses, designed not just for local guidance, but for broader maritime safety. One of the most significant early modern lighthouses was the Eddystone Lighthouse off the coast of Plymouth, England. Its story is one of persistent engineering challenge and human ingenuity against the relentless power of the sea. The Eddystone Rocks, a treacherous reef submerged at high tide, had claimed countless ships. The first attempt to build a lighthouse there was undertaken by Henry Winstanley in the late 17th century. His structure, completed in 1699, was a remarkable wooden octagonal tower, adorned with numerous projections and elaborate ironwork. Winstanley was so confident in his design that he reportedly wished for the fiercest storm to test its strength. Tragically, in the Great Storm of 1703, his wish was granted, and the lighthouse, along with Winstanley himself and his keepers, was swept away without a trace. The destruction of Winstanley's lighthouse did not deter the need for a beacon on Eddystone. A second lighthouse was constructed by John Rudyard, a silk merchant with a keen interest in engineering. Rudyard's design, completed in 1709, was a conical wooden structure, built with interlocking timbers and clad in iron. It stood for nearly 50 years, a testament to its sturdy construction. Its light was provided by 24 candles, a significant improvement over open fires, though still a relatively dim illumination by later standards. However, in 1755, a fire broke out in the lantern room, possibly from a spark from one of the candles, and the entire wooden structure was consumed by flames. The third Eddystone Lighthouse, and arguably the most famous, was designed and built by John Smeaton, a civil engineer often regarded as the father of civil engineering. Smeaton's approach was revolutionary. He chose to build with stone, recognizing the limitations of wood in such a harsh marine environment. He developed a hydraulic lime mortar that could set underwater, a crucial innovation for building on the exposed reef. Most famously, Smeaton pioneered the use of interlocking dovetailed blocks of granite, a technique inspired by the shape of an oak tree, to provide exceptional stability against the force of the waves. His Eddystone Lighthouse, completed in 1759, stood for over 120 years, a monument to his engineering genius. Its success profoundly influenced lighthouse construction worldwide, demonstrating the superiority of stone and the importance of a robust, integrated design. The light itself was initially provided by 24 candles, later replaced by oil lamps with reflectors. The evolution of the light source itself was as crucial as the structural integrity of the towers. From open fires and simple candles, the next significant step was the adoption of oil lamps. Early oil lamps, however, often produced a weak, flickering light and required frequent trimming of wicks. The quality of the oil also varied greatly, affecting the brightness and consistency of the flame. Whale oil, particularly sperm whale oil, became a preferred fuel due to its cleaner burn and brighter flame. But its availability was dependent on the whaling industry, which had its own environmental and economic consequences. The true revolution in lighthouse illumination came with the invention of the Argand lamp in the late 18th century by Aimé Argand. This lamp featured a cylindrical wick, allowing air to flow both inside and outside the flame, producing a much brighter, steadier, and cleaner burning light than previous designs. The Argand lamp, when combined with parabolic reflectors, dramatically increased the effective range and intensity of lighthouse beams. These reflectors, typically made of polished metal, were shaped to gather the light from the lamp and project it outwards in a concentrated beam, rather than allowing it to dissipate in all directions. This was a significant leap forward, making lighthouses far more effective at long distances. The next major innovation, and perhaps the most iconic symbol of lighthouse technology, was the Fresnel lens. Invented by Augustin Jean Fresnel, a French physicist, in the early 19th century, this lens system fundamentally transformed lighthouse optics. Prior to Fresnel, lenses were solid, thick pieces of glass, which absorbed a significant amount of light and were incredibly heavy and expensive to produce in large sizes. Fresnel's genius was to divide a large lens into a series of concentric rings, each a separate prism. This design allowed for a much larger aperture and a shorter focal length, meaning the lens could capture and refract a far greater proportion of the light from the lamp into a powerful, parallel beam. The Fresnel lens was a marvel of optical engineering. It consisted of a central plano-convex lens, surrounded by a series of annular prisms and reflecting prisms. The central lens and the inner rings of prisms bent the light through refraction, while the outer rings used total internal reflection to redirect light that would otherwise escape. This intricate design allowed a relatively small light source to produce an incredibly powerful and focused beam, visible for many miles out to sea. The efficiency of a Fresnel lens was astounding, capturing up to 85% of the light emitted by the lamp, compared to less than 20% for earlier parabolic reflectors. Fresnel lenses were classified into orders based on their size and focal length. A first-order lens, the largest, could be several meters tall and weigh several tons, producing a beam of immense power. These were typically used for major coastal lighthouses. Smaller orders, such as second, third, or fourth, were used for harbor lights or less critical navigational points. The precision required to manufacture these lenses was immense, and their construction involved highly skilled artisans. The individual glass segments had to be ground and polished to exacting standards, and then perfectly assembled into a robust brass framework. The introduction of the Fresnel lens not only improved the brightness and range of lighthouses, but also allowed for the creation of distinct light characteristics. By rotating the lens assembly around a stationary lamp, a flashing or occulting light could be produced. Different arrangements of lenses and panels could create unique patterns: a single flash, a group of flashes, or a steady light interrupted by periods of darkness. These characteristics, known as signatures, allowed mariners to identify specific lighthouses even in the darkest and stormiest conditions, providing crucial information for their navigation. The rotation of these massive lenses was initially achieved by complex clockwork mechanisms driven by falling weights, requiring the keeper to wind them regularly. The life of a lighthouse keeper, especially during this era of mechanical marvels, was one of constant vigilance and demanding labor. The keeper's duties were extensive and critical. Every evening, as dusk approached, the lamp had to be lit. This involved carefully cleaning the lamp, trimming the wick, and ensuring a steady supply of fuel, often kerosene or paraffin oil, by the late 19th century. The intricate Fresnel lens, a masterpiece of glass and brass, required meticulous cleaning and polishing to maintain its optical efficiency. Dust, salt spray, and even insects could obscure the light, so the keeper would carefully wipe down every prism and panel, often multiple times a day. The clockwork mechanism that rotated the lens also demanded constant attention. Keepers would have to wind the weights, often heavy lead or cast iron, every few hours, day and night. This winding process was physically demanding, often involving cranking a handle for several minutes to raise the weights to the top of the tower. The rhythmic whirring and ticking of the clockwork machinery became a constant backdrop to the keeper's life, a mechanical heartbeat that ensured the light's steady rotation. Any malfunction could be catastrophic, so keepers were trained to perform basic repairs and maintenance on these complex mechanisms. Beyond the lamp and lens, the entire lighthouse structure was the keeper's responsibility. This included maintaining the integrity of the tower itself, checking for cracks or damage from storms, and ensuring all windows and doors were secure. The living quarters, often within the tower or in an adjacent building, also needed to be kept clean and habitable. Supplies, food, fuel, spare parts had to be managed carefully, especially in isolated offshore lighthouses where resupply might only occur every few weeks or months, weather permitting. The isolation of lighthouse life was a defining characteristic. Many lighthouses were built on remote islands, exposed rock formations, or distant headlands, far from towns and communities. The keepers, often living with their families in earlier times, or in shifts with other keepers, developed a unique rhythm of life dictated by the sea and the light. Days were spent on maintenance, cleaning, and preparing for the night. Nights were spent in the lantern room, watching the light, monitoring the weather, and keeping a lookout for passing ships. The weather was a constant companion, and often an adversary. Storms could rage for days, battering the tower with waves and wind. The roar of the tempest, the shuddering of the structure, and the relentless spray against the lantern glass were all part of the keeper's experience. In such conditions, the keeper's vigilance was paramount. They might have to manually turn the lens if the clockwork failed, or constantly clear the lantern glass of ice or salt buildup to ensure the light remained visible. The foghorn, another vital navigational aid, also required attention, often powered by steam or compressed air, its mournful blast cutting through the thickest fog. The solitude could be profound. Weeks could pass without seeing another human face besides fellow keepers. This isolation fostered a strong sense of self-reliance and often a deep connection to the lighthouse itself. Keepers became intimately familiar with every creak and groan of their tower, every nuance of the surrounding sea and sky. They were often keen observers of nature, noting changes in bird migration, marine life, and weather patterns. Their journals, when they kept them, often contained detailed observations of these natural phenomena, alongside meticulous records of lamp performance and passing vessels. Despite the hardships, many keepers found a deep satisfaction in their work. There was a profound sense of purpose in knowing that their tireless efforts were saving lives and guiding ships safely through treacherous waters. The light they tended was a beacon of hope, a symbol of safety and reassurance for mariners far from shore. The rhythmic sweep of the beam across the dark ocean became a personal connection, a silent conversation between the keeper and the vast, often unforgiving sea. The stories of lighthouse keepers are filled with acts of heroism, quiet dedication, and moments of profound human resilience. There are tales of keepers battling storms to keep the light burning, rescuing shipwrecked sailors, or enduring weeks of isolation with dwindling supplies. These individuals were not just tenders of lamps. They were guardians of the coast, silent sentinels whose commitment often went unsung. Their lives were interwoven with the history of maritime navigation, a vital link in the chain of safety that allowed global trade and exploration to flourish. The transition from oil lamps to electric lights marked another significant technological leap in the late 19th and early 20th centuries. Electric arc lamps and incandescent bulbs offered a much brighter and more consistent light source, eliminating the need for constant wick trimming and fuel replenishment. However, the early adoption of electricity in lighthouses presented its own challenges. Remote lighthouses often required their own power generation systems, such as generators powered by steam engines or internal combustion engines, which added another layer of mechanical complexity and maintenance. With electric lights, the intensity of the beam could be further increased, and the reliability improved. The rhythmic flashing patterns could be precisely controlled by electrical timers and mechanisms, reducing the reliance on intricate clockwork. Despite these advancements, the role of the keeper remained essential. The new electrical systems still required monitoring, maintenance, and troubleshooting. Generators needed fuel, batteries needed charging, and the entire system had to be kept in perfect working order to ensure the light never failed. The advent of automated lighthouses, particularly in the latter half of the 20th century, gradually brought an end to the era of the resident lighthouse keeper. Advances in electronics, reliable power sources like solar panels and batteries, and remote monitoring systems meant that lighthouses could operate autonomously for extended periods. The iconic figure of the solitary keeper, tending the lamp through the night, slowly began to fade from the maritime landscape. This automation, while increasing efficiency and reducing operational costs, also marked the end of a unique way of life. The last manned lighthouses in many countries were automated in the late 20th century, often with a mix of nostalgia and practicality. The keepers, whose families had sometimes served for generations, faced a profound change in their profession. While the lights continued to shine, the human presence, the silent vigil, and the intimate connection between keeper and tower began to recede into history. Yet the legacy of the lighthouse keeper endures. Their stories, their dedication, and the very structures they maintained continue to captivate the imagination. The lighthouses themselves, now often preserved as historic landmarks, stand as enduring testaments to human ingenuity and perseverance against the forces of nature. They remind us of a time when human hands and unwavering commitment were the sole guarantees of safe passage across the vast, often perilous oceans. The light continues its silent work, a steadfast guardian against the perils of the deep, a silent promise of safe passage. The rhythmic pulse of the light, the steady presence of the tower, and the quiet devotion of its purpose combine to offer a profound sense of security, a gentle, guiding presence in the darkness, inviting a deep and peaceful rest. The history of these guiding lights, from ancient fires to automated beacons, is a story of constant innovation, a testament to humanity's enduring need for safety and guidance in the vastness of the world. Each flash, each steady beam, carries with it the echoes of countless journeys, of storms weathered, and of safe harbors found. The quiet hum of the machinery, the gentle sweep of the beam, these are the lullabies of the sea, inviting a deeper sense of peace and tranquility. The quiet hum of the machinery, the gentle sweep of the beam, these are the lullabies of the sea, inviting a deeper sense of peace and tranquility. This enduring presence, this constant vigilance, was once the sole responsibility of dedicated individuals. For centuries, the operation of lighthouses relied entirely on human hands. These were the lighthouse keepers, men and sometimes women, who lived in solitude or with their families, tending the light day and night. Their lives were inextricably linked to the rhythm of the sea, the changing weather, and the unwavering duty to maintain the beacon. The daily routine of a keeper was demanding. It involved cleaning the intricate lenses, trimming wicks, refueling lamps, and meticulously winding clockwork mechanisms that rotated the light. Even in the calmest weather, the work was constant. During storms, it became a perilous struggle against the elements. The isolation of lighthouse life was a defining characteristic. Many lighthouses were built on remote islands, rocky shoals, or distant headlands, far from towns and cities. Communication with the mainland was often limited to scheduled visits from supply vessels, or in later years, telegraph or radio. To combat this isolation, a unique community formed around the lighthouses. This community extended beyond the keepers themselves to include the specialized vessels and crews that supported them. These were the lighthouse tenders, specially designed ships that served as lifelines. Lighthouse tenders delivered essential supplies: food, fresh water, fuel for the lamps, mail, and spare parts for the intricate machinery. They also transported new keepers to their stations and brought those on leave back to shore. These tenders were crucial for the survival and operation of the entire lighthouse network. The crews of these tender ships often formed close bonds with the isolated keepers they regularly visited. These visits were eagerly anticipated, breaking the monotony and bringing news from the outside world. The arrival of the tender was a significant event, a connection to civilization. On larger lighthouse islands, keepers sometimes kept gardens or even raised a few livestock, like chickens or goats. This helped to supplement their provisions and provided a small measure of self-sufficiency. It was a way to make the remote station feel a little more like home. Many lighthouse families lived in attached dwellings, experiencing the constant presence of the sea and the light. Children grew up with the sound of waves and the rhythmic flash of the beacon as a backdrop to their lives. Their playgrounds were often the rocky shores surrounding the tower. The first American lighthouse, Boston Light, established in 1716 on Little Brewster Island, exemplifies this early era of human-tended lights. It was not only the first lighthouse in what would become the United States, but also the first offshore lighthouse in America, requiring dedicated keepers from its inception. The administration and oversight of these vital navigational aids were complex. In the United States, the Lighthouse Service, established in 1789, was responsible for the construction and maintenance of American lighthouses. This dedicated government body ensured a standardized approach to lighthouse operations. Later, the United States Lighthouse Board, established in 1852, further standardized lighthouse construction and operation. This board brought a more systematic and scientific approach to lighthouse design, optics, and administration, aiming for greater efficiency and reliability. The Lighthouse Service in many countries was responsible for maintaining all aids to navigation, not just the towering lighthouses. This included buoys, daymarks, and lightships, floating lighthouses used in areas where building a fixed structure was impractical due to shifting sands or deep water. A lightship was essentially a vessel anchored in a specific location, equipped with a powerful light and fog signals. It served the same purpose as a lighthouse, guiding mariners, but with the flexibility of being deployed where a permanent structure could not be built. These were often lonely posts for their crews. The profession of a lighthouse keeper, despite its inherent isolation and dangers, was often considered noble and vital. Keepers were respected figures in maritime communities, their unwavering dedication providing safety for countless voyages. Their vigilance saved lives and prevented shipwrecks. Lighthouse inspectors would regularly visit stations to ensure proper maintenance and adherence to regulations. These inspections were thorough, checking everything from the cleanliness of the lenses to the condition of the fog signals and the keeper's logs. They ensured the lights were always performing optimally. The Lighthouse Board, in various countries, oversaw the administration and technical aspects of lighthouse operations. They made decisions on new constructions, technological upgrades, and the deployment of personnel. Their work was critical to the expansion and modernization of lighthouse networks. In the United States, the Lighthouse Board was eventually replaced by the Bureau of Lighthouses in 1910, reflecting an ongoing evolution in administrative structures. This change aimed to streamline operations and adapt to new technologies emerging in the early 20th century. Beyond the main lighthouses, there were also range lights, or leading lights. These were pairs of lighthouses or beacons that, when aligned, guided vessels along a safe channel. By keeping the two lights vertically aligned, mariners could stay on the correct course, avoiding hazards. These range lights were particularly useful in narrow waterways, river entrances, or areas with complex shoals. They provided a precise visual aid, allowing ships to navigate with confidence, even in challenging conditions. Their alignment was a critical navigational tool. The human era of lighthouse keeping, a centuries-long tradition, eventually gave way to technological advancements. The march of progress, while bringing greater efficiency and safety, also meant a profound change for the lives of those who had dedicated themselves to the light. The automation of lighthouses, beginning in the mid-20th century, gradually led to the phasing out of human keepers. This transition was a slow process, occurring over several decades as new technologies became reliable and cost-effective. The shift from oil lamps to electric lamps in lighthouses typically occurred in the early to mid-20th century. Electric lights were brighter, more consistent, and required less constant attention than their predecessors. This was a significant step towards automation. Automating lighthouses meant the eventual phasing out of resident lighthouse keepers. The intricate clockwork mechanisms were replaced by electric motors, and the manual cleaning and refueling tasks were minimized or eliminated. Sensors and remote monitoring systems took over many duties. For example, the last manned lighthouse in the United States, Boston Light, was automated in 1998. However, it retains a resident keeper for historical reasons, a testament to its long and storied past. This unique arrangement preserves the human connection to this historic beacon. Many lighthouses are now powered by solar panels, making them self-sufficient in remote locations. This sustainable energy source further reduces the need for human intervention, as there is no longer a requirement to transport fuel to the isolated stations. The technological evolution of lighthouses is a fascinating journey. It moved from open flames to oil lamps, then to incandescent bulbs, and finally to highly efficient LED lights. Each step brought greater reliability, brightness, and reduced maintenance. The transition to automation was not without its emotional impact. For generations, families had lived and worked in these towers, and the end of the keeper era marked the close of a significant chapter in maritime history. The lights, however, continued to shine. Lighthouses, even in their automation, continue to stand as symbols of safety and guidance on coastlines worldwide. Their purpose remains unchanged. Even if the method of achieving it has evolved, they are silent sentinels watching over the seas. Though automated, the legacy of lighthouses and their keepers endures, becoming symbols of history and hope. The stories of their past, the challenges faced, and the lives saved are woven into the fabric of maritime lore. Lighthouse logs meticulously kept by keepers recorded weather conditions, ship sightings, and any unusual events. These logs provide a valuable historical record of maritime activity, offering insights into past storms, shipping patterns, and the daily life at sea. The rhythmic sweep of the light across the waves could be a mesmerizing and calming sight from shore or sea. This steady, predictable pattern offered reassurance, a beacon of constancy in the vast and often unpredictable ocean. The study of lighthouses and their history is known as phairology. This field explores the architecture, technology, and human stories associated with these iconic structures, delving into their profound impact on navigation and culture. Many lighthouses are now preserved as historical sites, their lights still shining, often maintained by volunteers. These dedicated individuals ensure that the legacy of these structures continues, allowing visitors to experience their unique atmosphere and learn about their past. The enduring legacy of lighthouses is their quiet, unwavering dedication to guiding travelers safely through the night. They stand as monuments to human ingenuity and perseverance, their beams cutting through darkness and fog. Many lighthouses have been converted into museums, inns, or even private residences after automation rendered keepers redundant. This adaptive reuse ensures their preservation and allows new generations to appreciate their beauty and significance. Lighthouse design often reflected the architectural styles of their era, from classical towers to more utilitarian, modern structures. Each lighthouse has its own distinct character, shaped by its location, the materials available, and the prevailing architectural trends. The Lighthouse Museum preserves the history and artifacts of these crucial navigational aids. These museums house lenses, foghorns, keepers' tools, and personal effects, telling the stories of the people and technologies that kept the lights burning. Lighthouses were often the first point of contact for immigrants arriving by sea, symbolizing hope and new beginnings. Their light represented a safe arrival, a welcome to a new land, a promise of a brighter future after a long journey. The solitude of lighthouse life, while challenging, also fostered deep contemplation and a profound connection to the sea. Keepers often developed a unique understanding of the ocean's moods, its power, and its subtle changes. The final sweep of the light, a gentle reminder of the enduring presence of these silent guardians, continues to cast its glow across the water. It is a symbol of steadfastness, a constant in a changing world, offering comfort and direction. The gentle current of time carries us forward, much like the ocean's own steady flow. We have explored the steadfast lives of lighthouse keepers and the enduring symbolism of their lights. Now, we turn our attention to the very structures themselves, the towers that stand against the elements, silent sentinels on the edge of the world. These towers are not merely functional buildings. They are feats of engineering designed to withstand the relentless assault of wind and wave. Each one tells a story of human ingenuity and perseverance. Consider the materials used in their construction. Early lighthouses were often built from stone, quarried nearby, or transported with great effort. These stones were meticulously cut and fitted together, sometimes without mortar, relying on their sheer weight and precise interlocking to create a stable structure. Off the coast of Plymouth, England, provides a remarkable example. Its various iterations illustrate the evolution of lighthouse construction. The first, built by Henry Winstanley in the late 17th century, was an octagonal wooden structure anchored by iron bars. It was a pioneering effort, but it ultimately succumbed to a massive storm in 1703, taking Winstanley with it. The second Eddystone, designed by John Rudyard, was also primarily wooden, but it incorporated a conical shape for greater stability. It stood for nearly 50 years before being destroyed by fire. It was John Smeaton in the mid-18th century who revolutionized lighthouse construction with his Eddystone design. He chose granite blocks cut with dovetailed joints, mimicking the interlocking branches of an oak tree. This innovative technique created a single, immensely strong structure, resistant to both water penetration and the force of the waves. Smeaton's Eddystone stood for over 120 years, a testament to his engineering brilliance. This method of interlocking stone blocks became a standard for many subsequent rock lighthouses, particularly in exposed locations. The challenges of building on remote, wave-swept rocks were immense. Workers often had only a few hours each day, at low tide, to land on the rock and continue construction. Supplies had to be carefully ferried across treacherous waters. The Bell Rock Lighthouse, off the coast of Scotland, is another iconic example of this type of construction. Built by Robert Stevenson between 1807 and 1810, it is the world's oldest surviving sea-washed lighthouse. Its construction involved a temporary floating lightship and a massive effort to cut and transport the stone. The foundation stones were laid with great precision, forming a solid base against the powerful North Sea. The design of these stone towers often incorporated a tapering shape, wider at the base and narrowing towards the top. This conical or cylindrical form helps to deflect waves, reducing the impact force. The smooth, rounded surfaces also prevent water from accumulating and freezing, which could damage the structure. As technology advanced, so did the materials and methods used in lighthouse building. Cast iron emerged as a viable option in the 19th century. Iron lighthouses could be prefabricated in sections, transported to the site, and then bolted together. This significantly reduced construction time and cost, especially for lighthouses built on sandy shoals or coral reefs where traditional stone foundations were impractical. The screw pile lighthouse is a notable example of iron construction. Invented by Alexander Mitchell, these lighthouses featured iron piles with large screw-like blades at their base. These piles were literally screwed into the seabed, providing a stable foundation in soft ground. A superstructure, often a cottage-like dwelling for the keepers, was then built atop these piles. These structures were particularly common in the United States, particularly along the shallow coasts of the Chesapeake Bay and the Gulf of Mexico. They offered a relatively quick and cost-effective solution for marking navigational hazards in these areas. The graceful, spider-like appearance of screw-pile lighthouses, rising from the water, is quite distinctive. Another type of iron lighthouse is the skeletal tower. These open-frame structures, often made of wrought iron or steel, were lighter and cheaper to build than solid masonry towers. Their open design allowed strong winds and waves to pass through, reducing the structural load. They are particularly suited for exposed locations where solid towers might be impractical or too expensive. The Minot's Ledge Lighthouse, off the coast of Massachusetts, initially attempted a skeletal iron design. However, it too succumbed to a storm in 1851, highlighting the extreme forces at play in certain locations. Its replacement, a magnificent stone tower, became a symbol of perseverance, famously known for its all-iron signal, meaning it struck its bell every 30 seconds, day and night. Concrete also became an important material in lighthouse construction, especially in the 20th century. Reinforced concrete offered strength, durability, and versatility in design. It could be cast into various shapes and forms, allowing for more modern and streamlined lighthouse designs. The towering structures themselves are often divided into several sections. The foundation, whether solid rock, screw piles, or concrete, anchors the lighthouse to its base. Above this is the shaft or tower, which provides the necessary height for the light to be seen over the horizon. Inside the tower, a winding stairscape typically ascends to the lantern room. The number of steps can be considerable, often hundreds, a daily climb for the lighthouse keeper. These stairs were sometimes spiral, sometimes straight sections with landings, but always a physical challenge. The living quarters for the keepers were often integrated into the tower itself, particularly in offshore lighthouses. These cramped but functional spaces provided shelter from the elements, a place to eat, sleep, and maintain the equipment. In land-based lighthouses, the keeper's dwelling might be a separate house nearby. At the very top of the tower is the watch room, where the keeper would monitor the light and the surrounding sea. This room often offered panoramic views, essential for spotting ships in distress or observing changes in weather. Above the watch room is the lantern room, the heart of the lighthouse. This is where the lamp and the intricate optical apparatus are housed. The lantern room is typically enclosed by thick glass panes, designed to withstand storms while allowing the light to project clearly. A ventilation system was crucial here to dissipate the heat from the lamp and prevent condensation on the glass. The roof of the lantern room often features a ventilator ball or a similar structure, allowing hot air to escape and fresh air to enter, further aiding in temperature regulation and preventing fogging. The color and pattern of a lighthouse's daymark are also carefully chosen for identification. Some are plain white, others striped, or painted with distinctive bands of red, black, or yellow. These patterns help mariners identify a specific lighthouse during daylight hours, even before its light becomes visible. The height of a lighthouse is a critical factor in its effectiveness. The higher the light, the farther it can be seen. This is due to the curvature of the earth. A light at sea level would quickly disappear over the horizon. By elevating the light, its range is extended significantly. However, height alone is not the only consideration. The power of the lamp and the efficiency of the lens system also play crucial roles. A powerful lamp, combined with a well-designed lens, can project a beam of light many miles out to sea, even from a relatively modest height. The construction of lighthouses often involved incredible feats of logistics and labor. Imagine transporting massive stone blocks, sometimes weighing many tons, across rough seas and hoisting them into place hundreds of feet above the waves. Specialized cranes, often designed specifically for the project, were essential. The workers who built these lighthouses faced immense dangers. Storms could sweep away temporary structures or even entire sections of the lighthouse under construction. Falling debris, treacherous footing, and the constant threat of the sea made lighthouse building one of the most hazardous professions of its time. Yet these challenges were met with unwavering determination. The importance of lighthouses to maritime safety spurred engineers, architects, and laborers to push the boundaries of what was thought possible. Each completed lighthouse was a triumph of human will over the raw power of nature. The architectural styles of lighthouses vary widely, reflecting the era of their construction, the available materials, and the specific needs of their location. Some are grand, ornate structures, while others are starkly utilitarian. Some lighthouses are iconic for their distinctive shapes. The candy-striped towers of Cape Hatteras in the United States, or the elegant, classical lines of the Fer de Cordouan in France, stand as examples of architectural artistry. Even today, as many lighthouses are automated, their physical structures remain. They are preserved not just as historical monuments, but as enduring symbols of hope and guidance. They remind us of a time when human hands and keen eyes were the primary guardians of the sea lanes. The gentle current continues to flow, carrying us towards the quiet contemplation of the light itself, the very heart of the lighthouse's purpose. We have seen the strength of the towers. Now we will consider the brilliance they hold. The heart of any lighthouse is its light. For centuries, this light was a simple fire. Wood, coal, and even candles were used. These early lights were often unreliable. They were easily obscured by fog or heavy rain. The intensity was limited. The range was short. As maritime trade grew, better illumination was needed. Oil lamps began to replace open flames. Whale oil was a common fuel source. It burned more brightly and consistently. The wicks needed constant trimming. This was a keeper's vital task. Argand lamps, invented in the late 18th century, brought a significant improvement. They used a cylindrical wick and a glass chimney. This design increased light output dramatically. Multiple Argand lamps were often arranged together. They formed a powerful beam. The next great leap was the Fresnel lens. Augustin Jean Fresnel, a French physicist, developed it in the early 19th century. This revolutionary lens design used a series of concentric rings. These rings focused the light. They magnified its intensity. A small lamp could produce a beam visible for many miles. The first Fresnel lens was installed in France in 1823. It transformed lighthouse technology forever. These lenses were categorized by order. A first-order lens was the largest and most powerful. It could be several meters tall. It weighed many tons. Smaller orders were used for less critical or closer range lights. The intricate prisms and facets of a Fresnel lens are still admired today. They are masterpieces of optical engineering. They gather scattered light. They project it into a concentrated, powerful beam. This beam pierces the darkest night. It offers a steady, unwavering guide. The light still turns, a steady, silent promise. The light still turns, a silent promise through the tranquil night. The light still turns, a silent promise through the tranquil night, a testament to the ingenuity that transforms scattered illumination into a focused beacon. A technological leap that dramatically improved maritime safety in the 19th century and beyond. Before the widespread adoption of the magnificent Fresnel lens, lighthouse illumination relied on less efficient methods, often involving open fires, coal-burning grates, or arrays of oil lamps backed by parabolic reflectors, each struggling to achieve the penetrating power that the new optical system effortlessly delivered. Early lighthouses, such as the legendary Pharos of Alexandria, one of the 7 wonders of the ancient world, were said to have used massive bonfires atop their towering structures, their smoky plumes and flickering flames serving as rudimentary navigational aids visible from many miles at sea, though their range and reliability were heavily dependent on weather conditions. The Roman Empire, known for its engineering prowess, also constructed numerous lighthouses along its vast coastlines, often employing similar fire-based systems or simple oil lamps, their primary purpose being to guide ships into harbors and along established trade routes, much like the modern aids to navigation we see today. As centuries progressed, the quest for brighter and more consistent light sources continued, leading to innovations like the Argand lamp, invented in the late 18th century by Aimé Argand, which featured a tubular wick, allowing air to pass both inside and outside the flame, significantly increasing its brightness and efficiency compared to earlier flat-wick lamps. This improved oil lamp, often fueled by whale oil or colza oil derived from rapeseed, became a standard in lighthouses before the advent of kerosene and then electricity, providing a more stable and intense light that could be more effectively harnessed by early reflector systems. The parabolic reflector, a curved mirror designed to collect and project light rays into a parallel beam, was another crucial development, with early versions made from polished metal, often silvered copper, which helped to amplify the Argand lamp's output and direct it seaward. These reflector systems, though a significant improvement over open flames, still suffered from light loss and required constant cleaning and maintenance to retain their reflective properties, a task that fell squarely on the dedicated shoulders of the lighthouse keepers. The transition from these reflector-based systems to the revolutionary Fresnel lens marked a pivotal moment in lighthouse technology, as Augustin Jean Fresnel's invention in 1822 for the Cordouan Lighthouse in France transformed the very nature of maritime lighting by using a series of concentric rings of prisms and lenses to refract and reflect light into a powerful parallel beam with minimal energy loss. This groundbreaking design allowed a relatively small light source to produce an incredibly intense and far-reaching beam, making lighthouses visible from much greater distances and dramatically enhancing their effectiveness as navigational guides. The construction of these intricate Fresnel lenses was a marvel of precision engineering, requiring skilled artisans to grind and polish each individual prism and lens segment to exact specifications, ensuring that every piece contributed to the overall focusing power of the colossal apparatus. Lighthouse authorities around the world, recognizing the immense benefits of this new technology, rapidly adopted Fresnel lenses, replacing older, less efficient systems and ushering in a golden age of lighthouse construction and operation. The establishment of a lighthouse was a complex undertaking, often requiring extensive surveys of treacherous coastlines, careful consideration of prevailing weather patterns, and the identification of critical navigational hazards that necessitated a guiding light. Site selection was paramount, with engineers seeking elevated positions on headlands, islands, or even submerged reefs, places where the light could achieve maximum visibility and serve the greatest number of passing vessels. The construction itself presented formidable challenges, especially for lighthouses built on remote islands or exposed rock formations, where materials had to be transported by sea, often in perilous conditions, and construction crews faced the constant threat of storms and isolation. For lighthouses erected on submerged shoals or reefs, innovative engineering techniques were developed, such as the screw pile lighthouse, which consisted of an iron framework screwed into the seabed, or caisson lighthouses, which involved sinking a watertight chamber to the seabed and building the tower within its protective walls. The design of the lighthouse tower itself varied widely, reflecting local architectural styles, available materials, and the specific demands of the site, ranging from sturdy stone towers capable of withstanding the fiercest gales to elegant cast iron structures prefabricated on land and assembled on site. Stone lighthouses, often built from granite or local rock, were renowned for their strength and longevity, their massive walls providing an unyielding defense against the relentless pounding of ocean waves and the corrosive effects of sea spray. The construction of these stone towers often involved intricate masonry work, with interlocking blocks carefully shaped and fitted to create a robust and stable structure, sometimes incorporating a dovetailed or joggled joint system to enhance their resistance to lateral forces. Cast iron lighthouses, particularly popular in the mid-19th century, offered the advantages of faster construction and lower cost, as their components could be manufactured in foundries and then shipped to the site for assembly, a method particularly suited for remote or difficult-to-access locations. Beyond the structural integrity of the tower, the design also encompassed the living quarters for the keepers, the watch room where the lens revolved, and the lantern room itself, a delicate glass enclosure protecting the precious optical apparatus from the elements. The living arrangements within a lighthouse tower could be Spartan, especially in isolated stations, often consisting of small, circular rooms stacked one above the other, connected by a winding staircase that ascended hundreds of steps to the lantern. These quarters had to be self-sufficient, equipped with storage for food, water, and fuel, as resupply missions could be infrequent and unpredictable, particularly during harsh winter months when storms might cut off access for weeks at a time. The watchroom, located just below the lantern, served as the keeper's primary workspace, a place where they meticulously monitored the light, wound the clockwork mechanisms that rotated the lens, and kept detailed logs of weather conditions and passing vessels. The lantern room, the crown jewel of the lighthouse, was meticulously designed to maximize the light's visibility while protecting the delicate lens from wind, rain, and salt spray, typically featuring thick, curved glass panes set in a sturdy metal framework. The glass used in lantern rooms was often specially manufactured to be highly transparent and resistant to thermal stress, allowing the powerful beam to pass through unimpeded while enduring extreme temperature fluctuations and the corrosive marine environment. Ventilation was also a critical aspect of lantern room design, as the heat generated by the powerful light source and the need to prevent condensation on the lens required a constant flow of air, often achieved through a system of vents and louvers. Above the lantern room, a ventilator ball or cap served to draw out hot air and smoke, ensuring optimal operating conditions for the lamp and preventing soot buildup on the lens. The characteristic of a lighthouse light, its unique flashing or occulting pattern, was crucial for identification by mariners, allowing them to distinguish one light from another and determine their exact position along a coastline. These distinct patterns, known as characteristics, were achieved through various mechanisms, including rotating screens or shutters placed around the light source, or by the rotation of the Fresnel lens itself, which had specific panels designed to create flashes of light and periods of darkness. Early rotating mechanisms were often powered by intricate clockwork machinery, driven by descending weights, similar to a grandfather clock, requiring the keepers to manually wind these heavy weights multiple times throughout their watch. The specific timing of these flashes and eclipses was precisely regulated and published in nautical charts and light lists, essential publications that provided mariners with comprehensive information about all aids to navigation in a given region. The importance of these light characteristics cannot be overstated, as they provided a vital layer of safety for ships navigating in unfamiliar waters, or during periods of reduced visibility, allowing captains to confidently identify their location and plot a safe course. A fixed light, for instance, would burn steadily without interruption, while a flashing light would exhibit brief periods of illumination followed by longer periods of darkness, and an occulting light would show longer periods of light interrupted by brief periods of darkness. Group flashing lights would present a specific number of flashes in quick succession, followed by a longer period of darkness, such as FL210s, indicating 2 flashes every 10 seconds, a unique signature for that particular lighthouse. These patterns were carefully chosen to avoid confusion with nearby lights and to provide clear, unambiguous guidance to mariners, reducing the risk of groundings and collisions. The life of a lighthouse keeper was one of profound isolation, relentless responsibility, and unwavering dedication. A solitary existence often spent in the company of the sea, the wind, and the rhythmic sweep of the light. Keepers were meticulously selected for their reliability, physical stamina, and meticulous attention to detail, as the safety of countless lives depended on their vigilance and the uninterrupted operation of the light. Their duties were arduous and demanding, encompassing the constant cleaning and polishing of the lens, the trimming of wicks, the refueling of lamps, and the winding of the clockwork mechanisms that kept the lens rotating. Every day before dusk, The keeper would ascend to the lantern room, carefully light the lamp, and ensure that the lens began its nightly rotation, a ritual that marked the transition from day to night and the commencement of their solitary vigil. During the night, the keeper would maintain a constant watch, peering out into the darkness for any signs of trouble, listening to the sounds of the sea, and meticulously recording observations in the station logbook, documenting weather conditions, passing vessels, and any unusual occurrences. The logbook served as a vital record of the lighthouse's operations, providing a detailed account of daily life and any incidents that might have affected the light's performance, a testament to the meticulous nature of the keeper's work. In the morning, at dawn, the keeper would extinguish the lamp, carefully clean the lens and lantern room, and prepare the apparatus for the next night's duty, a cyclical routine that defined their existence. The cleaning of the intricate Fresnel lens was a particularly delicate task, requiring specialized cloths and solvents to remove any salt spray, dust, or soot without scratching the highly polished glass surfaces, ensuring maximum light transmission. Beyond their primary duty of tending the light, keepers were often responsible for a myriad of other tasks, including maintaining the lighthouse structure, operating fog signals, and providing assistance to shipwrecked mariners. Fog signals, such as bells, horns, or sirens, were crucial during periods of dense fog or heavy precipitation, when the light itself might be obscured, providing an auditory warning to ships navigating in close proximity to dangerous shoals or shorelines. Early fog signals included cannons fired at regular intervals, large bells rung manually or by clockwork mechanisms, and later, steam-powered whistles or compressed air horns, each designed to produce a distinctive sound that could penetrate the dense atmospheric conditions. The operation of these powerful fog signals was often deafening for the keepers, requiring them to endure prolonged exposure to intense noise, adding another layer of hardship to their already challenging lives. The isolation of lighthouse life often led to unique social dynamics among keepers, particularly in stations where multiple keepers were assigned, creating a small, self-contained community in the midst of the vast ocean. These small communities, often consisting of a head keeper and one or more assistant keepers, had to navigate the challenges of close quarters, limited privacy, and the absence of external social interaction, fostering a strong sense of camaraderie or occasionally intense friction. Families of keepers sometimes lived at the lighthouse, particularly in shore-based stations, but in offshore or remote island lighthouses, keepers often served long tours of duty, separated from their loved ones for extended periods, relying on infrequent supply boats for mail and provisions. The children of keepers often received their education directly from their parents or through correspondence courses, growing up in a unique environment shaped by the rhythms of the sea and the demands of the light. The role of women in lighthouse keeping, though less documented than that of men, was significant and often overlooked, with many women taking on the duties of their husbands or fathers, particularly after their passing or incapacitation. These lady keepers demonstrated remarkable resilience and dedication, performing all the arduous tasks associated with lighthouse operation, often while raising families in challenging conditions. One notable example is Ida Lewis, who served for decades at the Lime Rock Lighthouse in Rhode Island, renowned for her numerous daring rescues of shipwrecked sailors and her unwavering commitment to the light. Her bravery and unwavering commitment earned her national recognition and solidified her place as one of America's most celebrated lighthouse keepers. A testament to the strength and capability of women in this demanding profession. The advent of automation in the 20th century gradually transformed the world of lighthouses, slowly replacing human keepers with sophisticated machinery that could operate the light and fog signals remotely or autonomously. The development of reliable electric lamps, automatic lamp changers, and robust timing mechanisms meant that lighthouses no longer required constant human presence, leading to the gradual demanning of stations around the world. The first fully automated lighthouse in the United States was the Castle Hill Lighthouse in Newport, Rhode Island, automated in 1938, marking the beginning of a slow but inevitable transition away from human-tended lights. This technological shift, while improving efficiency and reducing operational costs, also brought an end to an era of romantic isolation and the unique culture that had developed around lighthouse keeping, leaving many former keepers with a profound sense of loss for their unique way of life. Today, most lighthouses around the world are fully automated, their powerful beams still sweeping across the waters, guided by modern electronics and powered by electricity or solar panels. Their intricate Fresnel lenses, often preserved as historical artifacts, or replaced by smaller, more efficient LED arrays. The maintenance of these automated lights is typically performed by technicians who visit the stations periodically, ensuring that all systems are functioning correctly and addressing any issues that may arise, a far cry from the daily vigilance of the traditional keeper. While the romantic image of the solitary lighthouse keeper persists in popular culture, the reality of modern aids to navigation is one of sophisticated technology operating silently and autonomously, a testament to continuous innovation in maritime safety. Despite the automation, many lighthouses continue to stand as cherished historical landmarks, their towering structures serving as enduring symbols of maritime heritage, attracting tourists and history enthusiasts who seek to connect with their rich past. Preservation societies and volunteer groups often dedicate themselves to the restoration and maintenance of these historic lighthouses, ensuring that their stories and their architectural beauty are preserved for future generations. Many former lighthouse keeper dwellings have been converted into museums, bed and breakfasts, or educational centers, offering visitors a glimpse into the unique lives of those who once tended the lights. These efforts help to keep alive the memory of the keepers and the vital role lighthouses played in safeguarding seafaring, reminding us of the enduring human spirit that sought to conquer the perils of the sea. The distinctive architecture of lighthouses, from the classic conical stone towers to the more utilitarian skeletal structures, reflects their specific environments and the engineering challenges overcome during their construction. Some lighthouses, particularly those on exposed rock formations, were designed with a wave-swept base, a robust, flared foundation intended to deflect the immense force of breaking waves, preventing them from undermining the tower's stability. The interior of many lighthouses features a central spiral staircase, often made of cast iron, winding its way upwards through the tower, providing access to the various levels and culminating in the lantern room. This internal structure was not only functional, but often aesthetically pleasing, with ornate railings and polished steps, reflecting the pride taken in their construction. The color patterns of lighthouses, often painted in distinctive bands of white, red, or black, served as a daymark, allowing mariners to identify specific lighthouses during daylight hours when the light itself was not active. These unique color schemes, combined with the tower's architectural style, provided additional visual cues for navigation, complementing the light's characteristic pattern at night. For instance, a lighthouse might be painted with alternating red and white bands, or a solid white tower with a black lantern room. Each combination offering a unique visual signature that could be cross-referenced with nautical charts. These day marks were particularly important in areas with multiple lighthouses or complex coastlines, helping to prevent confusion and ensure accurate position fixing. The placement of lighthouses was often part of a larger network of aids to navigation, including buoys, beacons, and lightships, all working in concert to guide vessels safely along shipping lanes and into harbors. Lightships, essentially floating lighthouses, were deployed in areas where constructing a fixed lighthouse was impractical due to deep water, shifting sands, or extreme exposure, serving as temporary or permanent navigational markers in challenging locations. These sturdy vessels, often painted bright red with the name of their station emblazoned on their sides, carried powerful lights and fog signals, enduring the same harsh conditions as their land-based counterparts, their crews facing similar challenges of isolation and danger. The crews of lightships, much like lighthouse keepers, maintained a constant vigil, ensuring their lights and fog signals were operational, providing essential guidance in critical offshore areas. The technology of lighthouse illumination continued to evolve even after the Fresnel lens, with the introduction of incandescent oil vapor lamps in the late 19th century, which used pressurized kerosene to create a much brighter and more efficient flame than earlier oil lamps. These vapor lamps, often referred to as incandescent oil vapor (IOV) lamps, produced an intense white light by heating a mantle to incandescence, similar to a gas lantern, further increasing the range and power of the lighthouse beam. The transition to electricity in the early 20th century marked another significant leap, allowing for even brighter and more reliable light sources, such as powerful arc lamps and later incandescent electric bulbs, which could be easily automated and controlled. The development of modern LED, light-emitting diode technology, in recent decades has provided an even more energy-efficient and long-lasting light source, capable of producing powerful, focused beams with minimal power consumption, further reducing the need for frequent maintenance and significantly extending the operational life of the light source. The sound of the foghorn, a deep, resonant blast that pierces through the densest fog, remains an iconic symbol of lighthouses, a haunting auditory warning that has saved countless lives over the centuries. Early foghorns were often massive brass trumpets or whistles, powered by steam or compressed air, producing a distinctive sound pattern that, like the light characteristic, was unique to each station. The design of fog signals evolved from simple bells and cannons to sophisticated diaphones and nautophones, which produced powerful, low-frequency sounds capable of traveling long distances through dense atmospheric conditions. These powerful sound emitters were carefully tuned to specific frequencies and patterns, ensuring that mariners could distinguish one fog signal from another, providing crucial auditory guidance when visual cues were completely obscured. The legacy of lighthouses extends beyond their practical function, deeply embedding itself in literature, art, and folklore, often symbolizing hope, guidance, and the enduring human struggle against the forces of nature. Their solitary grandeur and the unwavering dedication of their keepers have inspired countless stories, poems, and paintings, capturing the romantic allure and the profound isolation of these sentinels of the sea. The image of a lighthouse, standing steadfast against a raging storm, its beam cutting through the darkness, evokes a powerful sense of resilience and unwavering purpose, a beacon of safety in a turbulent world. These structures, once vital navigational tools, now serve as powerful reminders of our maritime past, and the ingenious ways humanity has sought to navigate and conquer the vast and unpredictable oceans. The process of building a lighthouse on a remote, wave-battered rock, such as the famous Eddystone Lighthouse off the coast of Cornwall, England, involved extraordinary feats of engineering and human endurance. The construction of the fourth Eddystone Lighthouse, designed by James Douglas and completed in 1882, required the creation of a temporary landing stage and the meticulous shaping and interlocking of massive granite blocks, each weighing several tons, to form a tower capable of withstanding the full fury of the Atlantic. Workers often lived on the rock for weeks at a time, enduring cramped conditions and the constant threat of being swept away by rogue waves. Their commitment, driven by the knowledge that their efforts would save countless lives. The precise dovetailing of the granite blocks, a technique known as joggled masonry, ensured that the tower acted as a single monolithic structure, resisting the immense lateral forces exerted by the waves. The transfer of supplies and personnel to offshore lighthouses was a hazardous operation, often involving small boats attempting to land on slippery rock ledges or being hoisted aboard by cranes, a dangerous dance with the unpredictable sea. Keepers and their families, when present, often had to wait for calm weather windows, sometimes for weeks, before they could be transported to or from their isolated posts, adding to the sense of detachment from the mainland. The resupply vessels, often specially designed for lighthouse service, carried everything from food and fresh water to fuel for the lamps and spare parts for the machinery, ensuring that the remote stations remained fully operational. These supply missions, often undertaken in challenging sea conditions, were critical for the survival and continued functioning of the lighthouses and their dedicated keepers. The unique architectural features of some lighthouses, such as the pepper pot design common in Canada's maritime provinces, or the distinctive barber pole stripes of certain American lighthouses, contributed to their individual identity and helped mariners distinguish them from one another. The pepper pot style, characterized by a squat conical tower with a small lantern room perched on top, often painted white with a red or black cap, was particularly prevalent in areas with strong winds and heavy snow, providing a sturdy and compact structure. The varied designs and color schemes were not merely aesthetic choices, but practical considerations, ensuring that each lighthouse possessed a unique visual signature that could be readily identified by day and by its light characteristic by night. The development of the lighthouse service in various countries often involved the establishment of dedicated government agencies, such as the United States Lighthouse Board, later absorbed by the U.S. Coast Guard, or Trinity House in the United Kingdom, which oversaw the construction, maintenance, and operation of all aids to navigation. These organizations were responsible for setting standards for lighthouse technology, training keepers, conducting surveys, and ensuring the consistent operation of the entire network of lights, playing a crucial role in the safety of maritime commerce. The meticulous record-keeping, scientific research, and engineering expertise employed by these agencies were instrumental in the continuous improvement of lighthouse technology and the reduction of maritime accidents. The decommissioning of lighthouses, as technology advanced and shipping routes changed, often led to their abandonment or repurposing, with many finding new life as private residences, tourist attractions, or even art installations. While the operational need for some lighthouses diminished, their cultural and historical significance often led to efforts to preserve them, ensuring that these iconic structures continue to stand as monuments to a bygone era. The process of decommissioning typically involved removing the light source and fog signal equipment. But the physical structure of the tower often remained, a silent sentinel overlooking the seas it once guided. These preserved lighthouses, stripped of their original function, continue to evoke a powerful sense of history and the enduring human connection to the sea. The enduring appeal of lighthouses lies in their dual nature as both practical engineering marvels and powerful symbols, embodying humanity's quest for safety, knowledge, and mastery over the natural world. Their stoic presence on rugged coastlines and isolated islands speaks to a timeless human desire for guidance and protection, a steadfast light in the face of uncertainty. The stories of the keepers, their solitary lives, and their unwavering dedication to their duty contribute to the mystique and romanticism surrounding these structures, making them far more than mere navigational aids. They are monuments to human ingenuity, resilience, and the profound connection between land and sea, continuing to inspire awe and wonder in all who behold their timeless beauty. As the early morning mists would often cling to the rugged coastlines, obscuring the treacherous shoals and jagged rocks that lay hidden beneath the swirling waters, the very first rudimentary lighthouses emerged from the necessity of maritime safety, evolving from simple bonfires lit on prominent headlands by local communities or monastic orders to more sophisticated structures as trade routes expanded and shipwrecks became increasingly costly. These initial beacons, though primitive, represented a monumental step in humanity's quest to conquer the dangers of the sea, offering a fleeting glimpse of safety to mariners navigating by starlight or the uncertain glow of a distant shore. The ancient world saw the construction of some truly remarkable navigational aids, with the legendary Lighthouse of Alexandria, also known as the Pharos of Alexandria, standing as one of the 7 wonders of the ancient world, a colossal structure whose light was said to be visible from many miles away, guiding ships into the bustling Egyptian port for over a millennium. Built by the Ptolemaic kingdom between 280 and 247 BC, this architectural marvel was reportedly over 100 meters tall, its upper section housing a furnace that projected a powerful light, possibly augmented by polished metal mirrors, a testament to the advanced engineering capabilities of its time. Beyond the grandeur of Alexandria, other ancient civilizations, including the Romans, also recognized the critical importance of coastal markers, constructing numerous lighthouses along their vast empire's shores, such as the famous Roman lighthouse at Dover, England, which still stands today as a testament to their enduring construction techniques. These Roman lighthouses, often built in strategic locations near harbors or along busy shipping lanes, employed wood fires or oil lamps as their light sources, requiring constant tending by dedicated individuals who understood the immense responsibility placed upon them to keep the flames burning brightly through the darkest nights. The engineering challenges of building these early towers were considerable, often involving the transportation of massive stone blocks and the development of robust foundations capable of withstanding the relentless assault of ocean waves and powerful winds, especially in exposed locations. The design of these ancient structures, while varying in style and scale, consistently prioritized visibility and durability, often featuring sturdy, tapering forms that could resist the lateral forces of storms and provide a stable platform for the light source. Moving into the medieval period, the tradition of lighthouse keeping continued, often under the auspices of religious orders or local guilds, who would maintain fires on watchtowers or in purpose-built structures, sometimes even ringing bells or sounding horns during fog to provide additional auditory warnings to mariners. These medieval beacons, though less technologically advanced than their Roman predecessors in some respects, nevertheless served a vital role in guiding coastal traffic and preventing shipwrecks, demonstrating a continuous human commitment to maritime safety despite periods of societal upheaval. The advent of more sophisticated lighting technology began to emerge in the late 17th and 18th centuries, marking a significant turning point in lighthouse history with the introduction of parabolic reflectors and improved oil lamps that could project a much stronger and more focused beam of light. These advancements allowed for the creation of distinct light characteristics, such as flashing or occulting patterns, which enabled mariners to identify specific lighthouses and determine their precise location along a coast, thereby greatly enhancing navigational accuracy. The Eddystone Lighthouse, off the treacherous coast of Cornwall, England, stands as a powerful symbol of human perseverance against the formidable forces of nature, with its various iterations illustrating the relentless pursuit of durable and effective lighthouse design. The first Eddystone, completed in 1699 by Henry Winstanley, was an audacious timber structure. Despite its innovative design, succumbed to a massive storm in 1703, tragically taking Winstanley and all his keepers with it, a stark reminder of the immense dangers faced by early lighthouse builders and tenders. John Rudyard's second Eddystone Lighthouse, built from 1708 to 1709, was a more robust conical timber and iron structure, proving more resilient for several decades before it too was destroyed by fire in 1755, highlighting the ongoing challenges of material science and fire safety in such exposed environments. It was John Smeaton's third Eddystone Lighthouse, constructed between 1755 and 1759, that truly revolutionized lighthouse engineering, utilizing interlocking granite blocks and a dovetailed construction technique inspired by the natural strength of an oak tree, which allowed it to withstand the fiercest storms for over 120 years, establishing a new standard for lighthouse construction worldwide. Smeaton's innovative use of hydraulic lime, a type of cement that could set underwater, was crucial for the foundation work, allowing him to lay the base stones directly on the submerged rock, a groundbreaking technique that greatly improved the stability and longevity of the structure. The design of Smeaton's Eddystone, with its broad base tapering upwards and its smooth, curved exterior, was meticulously engineered to deflect the immense force of breaking waves, minimizing the impact and preventing the accumulation of water on the tower itself. The construction process was an arduous undertaking, with workers often battling fierce gales and towering seas to quarry, transport, and meticulously fit each massive granite block into place, a testament to their unwavering dedication and the perilous conditions under which they labored. The success of Smeaton's Eddystone Lighthouse not only saved countless lives and ships, but also inspired a new era of lighthouse building, demonstrating that with sound engineering principles and robust materials, even the most exposed and dangerous locations could be tamed by human ingenuity. The 19th century witnessed a golden age of lighthouse construction and technological innovation, driven by the increasing volume of global trade and the urgent need for more reliable and powerful navigational aids. This period saw the widespread adoption of the Fresnel lens, invented by Augustin Jean Fresnel in 1822, which represented a monumental leap forward in lighthouse optics, dramatically increasing the intensity and range of a lighthouse beam, while simultaneously reducing fuel consumption. The Fresnel lens, composed of a central plano-convex lens surrounded by concentric rings of prisms, worked by refracting and reflecting light, concentrating it into a powerful parallel beam that could be seen from much greater distances than previous lighting systems. This ingenious optical device transformed lighthouse technology, allowing for the creation of distinct light signatures, such as fixed, flashing, or occulting lights, each with a unique characteristic that mariners could use to identify a specific lighthouse and pinpoint their position on a chart. Different orders of Fresnel lenses were developed, ranging from the massive first-order lenses used in major coastal lighthouses, capable of projecting light for tens of miles, down to smaller sixth-order lenses used for harbor lights or minor navigational aids, each meticulously crafted to optimize light output for its specific purpose. The precision engineering required to manufacture these lenses was extraordinary, involving the careful grinding and polishing of numerous glass prisms and lenses, which were then assembled into intricate brass frames, often weighing several tons. The introduction of clockwork mechanisms to rotate these massive lenses allowed for the creation of rhythmic flashing patterns, further enhancing the distinctiveness of each lighthouse and providing crucial information to sailors navigating in challenging conditions. The development of more efficient fuel sources also played a significant role during this era, transitioning from whale oil to colza oil, then to kerosene, and eventually to incandescent oil vapor lamps, each offering a brighter and more consistent light output. The lives of lighthouse keepers during this golden age were characterized by isolation, discipline, and an unwavering commitment to their duty, often residing in remote towers with their families, far removed from the conveniences of mainland society. Their daily routines were meticulously structured, revolving around the constant maintenance of the lamp and lens, ensuring the clockwork mechanism was wound and meticulously cleaning the glass components to maximize light transmission. Keepers were also responsible for maintaining detailed logbooks, recording weather conditions, passing ships, and any unusual occurrences, providing valuable data for maritime authorities and contributing to the broader understanding of coastal environments. The isolation of lighthouse life often fostered a unique sense of camaraderie among keepers, who would communicate with each other through flag signals or later by telegraph, sharing news and offering support across the vast expanses of the sea. The construction of lighthouses during the 19th century also pushed the boundaries of civil engineering, with engineers like Robert Stephenson and Thomas Stephenson in Scotland, and Augustin Fresnel's brother Léonard Fresnel in France, pioneering new techniques for building towers in increasingly challenging and exposed locations. The Stephenson family in particular became synonymous with lighthouse engineering, designing and overseeing the construction of some of Scotland's most iconic and enduring lighthouses, including the Bell Rock Lighthouse, considered one of the greatest engineering feats of its time. Built on a submerged reef 11 miles off the coast of Angus, Scotland, the Bell Rock Lighthouse, completed in 1811 by Robert Stephenson, utilized Smeaton's interlocking stone techniques, but on an even grander scale, taking 4 years to construct under incredibly arduous conditions. The sheer audacity of building a permanent structure on a rock that was submerged for most of the day, constantly battered by fierce North Sea gales, speaks volumes about the determination and ingenuity of its builders. The construction of the Bell Rock Lighthouse involved the establishment of a temporary living quarters on stilts near the reef, where workers would reside for weeks at a time, enduring cramped conditions and the constant roar of the sea, a testament to their resilience and dedication. The meticulous planning and execution of the project included the development of specialized tools and techniques for quarrying, transporting, and precisely fitting the massive stone blocks, ensuring the structural integrity of the tower against the relentless forces of the ocean. The Bell Rock Lighthouse also incorporated a rotating Fresnel lens, one of the earliest applications of this revolutionary technology, further cementing its status as a landmark achievement in lighthouse engineering and maritime safety. Its enduring presence, having guided ships safely for over 2 centuries, stands as a powerful symbol of human triumph over the raw power of nature, a silent sentinel watching over the turbulent waters. Beyond the grand coastal lighthouses, a vast network of smaller lights, buoys, and daymarks also played a crucial role in guiding mariners through complex waterways, harbors, and channels, forming a comprehensive system of aids to navigation. These smaller lights, often automated or requiring less frequent tending, provided localized guidance, marking safe passages, identifying submerged dangers, and helping ships navigate tricky approaches to port. The development of reliable fog signals, such as bells, whistles, and later powerful diaphones and sirens, became equally important for maritime safety, providing auditory warnings when visibility was reduced to zero by dense fog or heavy precipitation. These fog signals, often mechanically operated and requiring significant power, would emit distinctive patterns of sound, allowing mariners to determine their proximity to a lighthouse even when its light was obscured. The evolution of power sources for lighthouses also progressed significantly, moving from manual winding of clockwork mechanisms to automated systems powered by weights, then to internal combustion engines, and eventually to electricity and solar power. The transition to electricity, particularly with the advent of powerful incandescent lamps and later arc lamps, allowed for even brighter and more reliable light sources, further extending the range and effectiveness of lighthouses. The development of acetylene gas lamps, particularly for remote or minor lights, provided a reliable and long-burning light source that required less frequent maintenance, paving the way for the eventual automation of many lighthouses. These technological advancements gradually reduced the need for resident keepers, leading to the eventual automation of most lighthouses around the world by the late 20th century. The automation of lighthouses, while representing a triumph of technology and efficiency, also brought about a profound cultural shift, marking the end of an era for the dedicated men and women who had committed their lives to keeping the lights burning. The gradual removal of keepers from their lonely posts meant the loss of a unique way of life, a profession steeped in tradition, solitude, and unwavering responsibility. While automation eliminated the human element of potential error and allowed for more consistent operation, it also removed the immediate human presence that could respond to unforeseen emergencies or provide assistance to distressed mariners. The stories of keepers, their resourcefulness in isolation, and their often heroic actions during storms or shipwrecks became an integral part of the maritime folklore surrounding these iconic structures. Many lighthouses, particularly in the United States, were equipped with powerful steam-powered foghorns, which would emit a low, mournful blast during periods of low visibility, their deep resonance carrying for miles over the water, a sound that became synonymous with the mystery and danger of the sea. These massive horns, sometimes requiring enormous boilers and significant amounts of coal or oil to operate, were a vital component of a lighthouse's navigational suite, providing an essential warning system when the light itself was rendered useless by the elements. The distinctive sound patterns of these foghorns, much like the light characteristics, were carefully chosen to allow mariners to identify specific stations. adding another layer of information to their navigational charts. The sheer volume and power of these early fog signals were often astounding, designed to penetrate the thickest fogs and reach ships far out at sea, guiding them away from peril. The construction of lighthouses in the United States, particularly along the treacherous Atlantic and Pacific coasts, presented unique engineering challenges, with the Lighthouse Board, established in 1852, playing a crucial role in standardizing and expanding the nation's network of navigational aids. The Lighthouse Board, comprised of military engineers and civilian scientists, brought a systematic and scientific approach to lighthouse design and construction, drawing upon the lessons learned from European engineers, while also developing innovative solutions for America's diverse coastlines. One of the most remarkable feats of American lighthouse engineering was the construction of the Minot's Ledge Lighthouse off the coast of Massachusetts, a highly exposed rock notorious for its numerous shipwrecks. The first Minot's Ledge Lighthouse, an iron pile structure, was tragically destroyed in a storm in 1851, killing its two keepers, a stark reminder of the immense power of the ocean. The second Minot's Ledge Lighthouse, completed in 1860, was a monumental achievement, a granite tower meticulously constructed using interlocking dovetailed blocks, similar to Smeaton's Eddystone, but on an even more challenging site, taking 6 years of arduous labor to complete. The construction of Minot's Ledge involved working only during low tide and in calm weather, with workers often battling freezing spray and powerful waves, a testament to their extraordinary courage and perseverance. The precise fitting of each massive granite block, often weighing several tons, was crucial for the structural integrity of the tower, ensuring it could withstand the relentless pounding of the Atlantic storms. The successful completion of Minot's Ledge Lighthouse, which still stands today, became a symbol of American engineering prowess and a beacon of hope for mariners navigating the dangerous New England coast. Further west, the challenging conditions of the Pacific Northwest, with its rugged coastline, dense fogs, and powerful currents, also necessitated the construction of robust and enduring lighthouses, often built on remote islands or precipitous cliffs. The Tillamook Rock Lighthouse off the coast of Oregon stands as another testament to human determination. Built on a remote basaltic island that was constantly battered by enormous waves, earning it the nickname Terrible Tilly. The construction of Tillamook Rock, completed in 1881, involved blasting a flat platform on the island's summit and then constructing a sturdy stone structure, a project that claimed the life of one worker and tested the limits of human endurance. Keepers at Tillamook Rock endured extreme isolation and the constant roar of the ocean, sometimes going for weeks without resupply due to severe weather. Their lives a testament to the harsh realities of lighthouse service. The design of lighthouses also evolved to incorporate various architectural styles, reflecting the prevailing aesthetics of their time and region, ranging from the classical elegance of some European towers to the more utilitarian and robust designs of American lighthouses. Some lighthouses, particularly those built in the late 19th and early 20th centuries, incorporated ornate ironwork, intricate brick patterns, or even residential quarters integrated directly into the tower base, creating structures that were not only functional but also aesthetically pleasing. The height of a lighthouse was often determined by the desired range of its light and the elevation of its site, with some towers reaching hundreds of feet to ensure their beams could clear distant horizons or penetrate low-lying fogs. The characteristic daymark of a lighthouse, its unique paint scheme or architectural features, allowed mariners to identify it visually during daylight hours, providing an additional layer of navigational information. The materials used in lighthouse construction varied widely depending on local availability and engineering advancements, ranging from timber and brick to cast iron, steel, and reinforced concrete, each chosen for its durability and ability to withstand the harsh marine environment. Cast iron lighthouses, particularly popular in the mid-19th century, offered the advantage of prefabrication, allowing sections of the tower to be manufactured on land and then assembled on site, greatly reducing construction time and cost, especially in remote locations. These iron towers, often painted in distinctive colors, became a common sight along many coastlines, their slender forms standing in stark contrast to the more massive stone structures. Reinforced concrete, introduced in the early 20th century, provided even greater flexibility in design and superior resistance to seismic activity and wave action, becoming a preferred material for many modern lighthouse constructions. The maintenance of lighthouses was a continuous and demanding task, requiring regular inspections, repairs to the structure, repainting, and the meticulous upkeep of all mechanical and optical components. Keepers were skilled tradesmen, often adept at carpentry, masonry, plumbing, and electrical work, capable of performing a wide range of repairs to ensure the lighthouse remained operational in all conditions. The logistics of supplying remote lighthouses with fuel, fresh water, food, and other necessities were often complex, relying on specialized lighthouse tenders, sturdy vessels designed to navigate treacherous waters and deliver provisions to isolated stations. These tenders, often equipped with cranes and other heavy lifting gear, were essential for the sustained operation of the lighthouse network, connecting the keepers to the outside world and ensuring their vital work could continue uninterrupted. The unique challenges of constructing lighthouses on submerged shoals or shifting sands led to the development of caisson lighthouses, where a watertight chamber or caisson was sunk to the seabed and filled with concrete or stone to form a stable foundation. These innovative structures, such as the Roter Sand Lighthouse in Germany, built in the North Sea in the late 19th century, represented another triumph of engineering, allowing lighthouses to be placed in locations previously deemed impossible, greatly enhancing safety in busy shipping lanes. The construction of caisson lighthouses was a complex and dangerous undertaking, requiring specialized diving equipment and techniques to work on the seabed, often in strong currents and poor visibility. The successful deployment of these structures demonstrated humanity's relentless pursuit of safer navigation, pushing the boundaries of engineering to conquer even the most challenging marine environments. The stories of lighthouse keepers are replete with tales of heroism, resilience, and extraordinary dedication. From lone individuals battling raging storms to entire families enduring years of isolation to ensure the light never failed. Many keepers performed daring rescues of shipwrecked sailors, often risking their own lives in treacherous conditions, embodying the spirit of selfless service that defined their profession. The psychological toll of isolation and the constant pressure of responsibility were immense, yet keepers persevered, finding solace in their routines, the beauty of their surroundings, and the profound satisfaction of knowing their work saved lives. The passing of the lighthouse keeping era, while inevitable with technological progress, left a void in the maritime world, a sense of nostalgia for a time when human vigilance was the primary safeguard against the perils of the sea. Today, many historic lighthouses have been preserved as museums, tourist attractions, or even unique accommodations, allowing visitors to experience a glimpse into the lives of the keepers and appreciate the architectural and engineering marvels they represent. These preserved lighthouses serve as tangible links to our maritime past, educating new generations about the importance of navigational aids and the human stories behind their construction and operation. The conservation efforts surrounding these structures ensure that their legacy endures, reminding us of the enduring human desire for guidance and protection, a steadfast light in the face of uncertainty. The continued fascination with lighthouses, their iconic silhouettes against dramatic seascapes, and the romanticism surrounding their solitary existence ensures their place as cherished symbols of hope and resilience for generations to come. The enduring human desire for guidance and protection, a steadfast light in the face of uncertainty, has propelled the evolution of lighthouses from rudimentary bonfires to sophisticated technological marvels, each iteration reflecting advancements in engineering, optics, and maritime navigation. Early coastal markers, often simple piles of stones or elevated platforms for burning wood, provided only a localized and often unreliable beacon, their effectiveness heavily dependent on weather conditions and the availability of fuel. The transition from open flames to more controlled and efficient light sources marked a significant turning point in lighthouse technology, with early oil lamps and candles gradually giving way to more powerful and persistent illumination methods. One of the most pivotal innovations in lighthouse history was the development of the Fresnel lens, a revolutionary optical system designed by French physicist Augustin-Jean Fresnel in the early 19th century, which dramatically magnified the intensity and reach of a lighthouse beam. This ingenious lens, composed of a central plano-convex lens surrounded by concentric rings of prisms, effectively captured and redirected nearly all the light emitted from the source, focusing it into a powerful, narrow beam that could be seen from much greater distances than previous reflective systems. Before Fresnel's invention, lighthouses primarily relied on parabolic mirrors, which, while an improvement over simple flames, suffered from significant light loss and produced a less concentrated beam, limiting their range and effectiveness. The Fresnel lens, with its intricate arrangement of glass elements, allowed for a much smaller light source to produce an incredibly bright and distant signal, fundamentally transforming maritime safety and navigation worldwide. The adoption of the Fresnel lens led to a classification system based on its size and power, with first-order lenses being the largest and most powerful, capable of projecting light many miles out to sea, often reaching horizons beyond 20 nautical miles. These magnificent first-order lenses, towering structures of polished glass and brass, were typically reserved for major coastal lighthouses and critical navigational points, serving as primary guides for transoceanic voyages and indicating significant landfalls. Smaller orders, such as second-order and third-order lenses, were employed in lighthouses marking secondary channels, harbor entrances, or dangerous shoals, each size precisely engineered to suit its specific navigational purpose and visibility requirements. The intricate craftsmanship involved in creating these lenses was extraordinary, requiring highly skilled glassmakers and opticians to grind and polish each individual prism and lens segment to exact specifications, ensuring optimal light transmission and beam focus. Beyond the lens itself, the mechanism for rotating the light also underwent significant evolution, moving from manual rotation by lighthouse keepers to sophisticated clockwork mechanisms powered by falling weights. These intricate clockwork systems, often resembling oversized grandfather clocks, required meticulous winding and maintenance to ensure the constant and precise rotation of the lens, creating the unique flash patterns that allowed mariners to identify individual lighthouses. The development of these reliable rotation mechanisms was crucial for establishing the distinctive character of each lighthouse. A specific sequence of flashes, occultations, or fixed lights that served as a unique identifier on navigational charts. This character, whether a single flash every 10 seconds or a group of 3 flashes followed by an eclipse, was a vital piece of information for sailors, enabling them to pinpoint their exact location along a coastline, even in the darkest and stormiest conditions. The lives of lighthouse keepers, those solitary guardians of the light, were inextricably linked to these mechanical wonders, as they were responsible for the daily operation, cleaning, and maintenance of the entire lighting apparatus. Their duties extended far beyond simply lighting the lamp. They meticulously polished every facet of the Fresnel lens to prevent any diminution of light intensity, wound the clockwork mechanism several times a day, and ensured a continuous supply of fuel for the lamp. The isolation inherent in their profession, particularly in remote offshore lighthouses, fostered a unique culture of self-reliance, ingenuity, and unwavering dedication to their critical role in maritime safety. Many keepers developed deep personal connections with their lighthouses, seeing them not merely as structures, but as living entities whose well-being depended entirely on their diligent care. The construction of lighthouses presented immense engineering challenges, especially for those built on isolated rocks or treacherous shoals far from shore, demanding innovative techniques to withstand the relentless assault of waves and weather. One of the most famous examples of such audacious engineering is the Eddystone Lighthouse, located off the coast of Plymouth, England, which saw several iterations before the successful completion of John Smeaton's revolutionary design in the late 18th century. Smeaton, often considered the father of civil engineering, pioneered the use of hydraulic lime, a type of concrete that could set underwater, and employed dovetailed blocks of granite that interlocked, creating a structure of unparalleled strength and resilience against the powerful ocean forces. This innovative construction method, where each stone was precisely cut to fit into its neighbors like a giant jigsaw puzzle, became a blueprint for subsequent offshore lighthouse construction, demonstrating the power of meticulous planning and robust materials. Another celebrated example of challenging lighthouse construction is the Bell Rock Lighthouse, situated on a submerged reef off the coast of Angus, Scotland, which was designed and built by Robert Stephenson between 1807 and 1810. This monumental achievement, often hailed as one of the 7 wonders of the industrial world, involved overcoming incredible logistical difficulties, including working only during low tide and battling ferocious storms that frequently swept away equipment and threatened the lives of the construction workers. Stephenson's design incorporated many of Smeaton's principles, but also introduced further refinements, such as a stronger base and a more streamlined profile to minimize wave impact, showcasing the continuous evolution of lighthouse engineering knowledge. The construction of Bell Rock, enduring for 4 years, with men living in temporary barracks built on stilts above the churning sea, stands as a testament to human perseverance and engineering brilliance in the face of nature's formidable power. The materials used in lighthouse construction varied widely, depending on local availability and the specific environmental challenges, ranging from robust stone and granite in areas prone to heavy seas, to brick and cast iron for more sheltered locations or those requiring quicker erection. Cast iron, in particular, gained popularity in the mid-19th century for its strength, durability, and the ability to be prefabricated in sections off-site, allowing for faster assembly on remote or difficult-to-access sites. These modular cast iron lighthouses could be shipped to distant colonies or isolated islands and erected with relative speed, making them a practical solution for expanding navigational aids across vast maritime networks. The skeletal iron lighthouses, with their open latticework structures, were particularly effective in hurricane-prone regions, as they allowed strong winds to pass through, reducing the structural stress that solid towers would experience. The interior architecture of lighthouses, though primarily functional, often featured ingenious designs to maximize living space and efficiency for the keepers, with spiral staircases winding upwards through the tower, connecting living quarters, watchrooms, and the lantern room itself. These spiral staircases, sometimes hundreds of steps long, were not merely a means of ascent, but also served as a central structural element, reinforcing the tower's stability and providing a continuous pathway for supplies and personnel. The living quarters, often compact and cleverly designed, included sleeping berths, a small kitchen, and storage areas, all arranged to make the most of the limited circular space within the tower. The watchroom, located just below the lantern, provided a sheltered vantage point for keepers to monitor the sea, observe shipping traffic, and ensure the light remained operational throughout the night, often equipped with telescopes and other navigational instruments. Beyond their primary function as navigational aids, lighthouses also played a crucial role in meteorology, with keepers regularly recording weather observations, including wind speed, direction, temperature, and sea conditions. This invaluable data, collected consistently over decades, contributed significantly to the understanding of local weather patterns and climate change, providing a rich historical archive for scientific study. Many lighthouses were equipped with anemometers, barometers, and rain gauges, and keepers were trained to meticulously document their readings, often transmitting them via telegraph or later by radio to central meteorological stations. The isolated locations of many lighthouses made them ideal outposts for long-term weather monitoring, offering insights into atmospheric and oceanic phenomena that were difficult to gather elsewhere. The advent of electricity marked another transformative phase in lighthouse technology, replacing oil and gas lamps with powerful electric arc lamps and later incandescent bulbs, dramatically increasing the intensity and reliability of the light. Electrification allowed for the automation of many tasks previously performed by keepers, such as lamp ignition and rotation, paving the way for the eventual demanning of many lighthouses around the world. The transition to electricity also enabled the development of more complex light characteristics, including synchronized flashing patterns and brighter, more consistent beams, further enhancing their effectiveness as navigational aids. However, the installation of electrical systems in remote lighthouses often required significant infrastructure development, including power generators, extensive wiring, and sometimes even undersea cables to connect them to mainland grids. The automation of lighthouses, beginning in the mid-20th century and accelerating towards its end, was driven by advancements in reliable power sources, such as solar panels and batteries, and sophisticated electronic control systems. These automated systems could manage the light's operation, monitor its performance, and even report malfunctions remotely, significantly reducing the need for a permanent human presence. While automation brought increased efficiency and reduced operational costs, it also signaled the end of an era for lighthouse keepers, whose centuries-old profession gradually faded into history. The last manned lighthouses in many countries were automated in the late 20th century, marking a poignant moment in maritime history and closing a chapter on the romanticized, solitary lives of these dedicated individuals. Despite automation, the fundamental principle of a lighthouse, to provide a reliable visual aid for navigation, remains unchanged. Though modern aids to navigation have diversified considerably to include radio beacons, GPS, and electronic charting systems. These technological advancements, while offering unprecedented precision, do not entirely replace the visual reassurance of a lighthouse beam, especially in situations where electronic systems might fail, or in areas with limited satellite coverage. The visual confirmation provided by a lighthouse, particularly in challenging weather conditions or when approaching unfamiliar coastlines, continues to be a critical component of safe navigation for many mariners. Lighthouses now often serve as part of a multi-layered system of aids to navigation, complementing electronic signals with their enduring visual presence. The distinct architectural styles of lighthouses reflect not only their geographical location and the available building materials, but also the prevailing architectural trends of their construction periods, ranging from classical revival to Art Deco. Some lighthouses, particularly those built in the 19th century, feature ornate detailing, decorative cornices, and elegant proportions, reflecting the aesthetic sensibilities of the Victorian era. Others, like the modern concrete towers, prioritize functionality and durability, showcasing a more minimalist and utilitarian design approach. The diverse array of lighthouse designs, from the candy-striped towers of Cape Hatteras to the rugged stone fortresses of the Scottish coast, contributes to their individual character and makes each one a unique landmark. The historical significance of lighthouses extends beyond their navigational utility, as many have witnessed pivotal moments in maritime history, including shipwrecks, wartime conflicts, and daring rescue operations. They stand as silent sentinels, bearing witness to centuries of human endeavor on the high seas, their lights piercing through countless storms and guiding untold numbers of vessels safely to port. During wartime, lighthouses often played a strategic role, sometimes serving as observation posts or even being targeted by enemy forces, highlighting their importance in national defense. The stories of heroic keepers who risked their lives to maintain the light during fierce gales or to rescue shipwrecked sailors further cement their place in maritime lore and national heritage. Conservation efforts surrounding these iconic structures are crucial for preserving their historical integrity and ensuring their continued existence for future generations, often involving meticulous restoration of the original lenses, mechanisms, and structural elements. Many lighthouses are now managed by historical societies, government agencies, or non-profit organizations dedicated to their preservation, transforming them into museums, educational centers, or unique accommodations. These conservation initiatives often face significant challenges, including the harsh marine environment that accelerates wear and tear, the high cost of specialized repairs, and the need to balance historical accuracy with modern safety standards. The painstaking work of restoring a Fresnel lens, for instance, requires highly specialized skills to clean, repair, and reassemble its delicate glass components without causing damage. The repurposing of lighthouses, once decommissioned from their active navigational duties, has created new opportunities for public engagement and appreciation, allowing visitors to explore their interiors, climb to the lantern room, and learn about their rich history. Many former keepers' dwellings have been converted into bed and breakfasts or vacation rentals, offering a unique opportunity to experience the solitude and grandeur of these coastal sentinels. These adaptive reuse projects not only generate revenue for maintenance, but also ensure that the stories and heritage of lighthouses remain accessible to a wider audience, fostering a deeper connection to maritime history. The educational programs offered at lighthouse museums often include exhibits on optics, engineering, and the daily lives of keepers, providing a comprehensive understanding of their multifaceted role. The cultural impact of lighthouses is profound, permeating literature, art, and popular culture as powerful symbols of hope, solitude, vigilance, and the human spirit's resilience against the forces of nature. Their iconic silhouettes against dramatic seascapes have inspired countless artists and photographers, capturing their timeless beauty and the romanticism associated with their isolated existence. Lighthouses frequently appear in novels, poems, and films, often serving as metaphors for guidance, introspection, or the enduring search for meaning in a vast and uncertain world. The enduring fascination with lighthouses, their iconic silhouettes against dramatic seascapes, and the romanticism surrounding their solitary existence ensures their place as cherished symbols of hope and resilience for generations to come. The sound signals associated with lighthouses, such as foghorns and bells, were equally vital for navigation in conditions of poor visibility, providing an auditory warning when the light itself could not penetrate the dense fog or driving rain. Early fog signals included cannons, bells, and even gongs, manually operated by keepers, each designed to produce a distinctive sound that could carry over the waves. The development of steam-powered foghorns in the late 19th century represented a significant advancement, producing a much louder and more consistent blast that could be heard from greater distances, often synchronized with the light's flash pattern. These powerful horns, with their deep resonant calls, became an iconic sound of the coast, a reassuring presence for mariners enveloped in a thick blanket of fog, guiding them away from treacherous shoals and rocky coastlines. The precise timing and distinct character of these fog signals, much like the light characteristics, were meticulously charted, allowing mariners to identify their location solely by sound when visual cues were absent. The maintenance of these intricate sound-generating mechanisms, which often involved complex machinery, boilers, and air compressors, added another layer of responsibility for lighthouse keepers. The transition to electrically powered diaphragm horns and later electronic fog signals further automated these auditory warnings, ensuring continuous operation without constant human intervention. Modern fog signals, often activated automatically by fog detectors, continue to provide an essential layer of safety, proving that even with advanced electronic navigation, the fundamental need for clear, unambiguous warnings remains paramount. The establishment of lighthouse boards and commissions in various countries, such as the United States Lighthouse Board and Trinity House in the UK, played a critical role in standardizing lighthouse construction, operation, and maintenance across vast coastlines. These organizations were responsible for surveying coastlines, identifying critical navigational points, designing new lighthouses, and overseeing their construction and staffing, ensuring a cohesive and effective network of aids to navigation. Trinity House, with its origins dating back to the 16th century, evolved from a guild of mariners into the primary lighthouse authority for England and Wales, demonstrating a long-standing commitment to maritime safety. The systematic approach adopted by these boards ensured that lighthouses were strategically placed, uniformly maintained, and continuously improved, contributing significantly to the overall safety of maritime trade and travel. The evolution of lighthouse technology also included the development of different types of illuminants, moving from whale oil and colza oil to kerosene, gas, and eventually electricity, each offering increased brightness, efficiency, and reliability. Whale oil, a common fuel in the early days, was eventually replaced due to its cost and the decline of the whaling industry, leading to the adoption of vegetable oils like colza. Kerosene, introduced in the mid-19th century, provided a much brighter and more stable flame than previous oils, becoming the dominant illuminant for several decades. The development of incandescent oil vapor lamps, which heated kerosene to produce a bright gas flame, further enhanced light intensity before the widespread adoption of electric lamps. Each shift in illuminated technology represented a significant step forward in the quest for a more powerful and dependable light source, directly impacting the range and effectiveness of the lighthouses. The sheer logistical challenge of supplying remote lighthouses, especially those on isolated islands or offshore rocks, required dedicated tender vessels that regularly delivered fuel, food, fresh water, mail, and relief keepers. These lighthouse tenders, often specially designed for navigating treacherous waters and mooring alongside difficult structures, were the lifeline for the keepers, bringing them essential provisions and their only connection to the outside world. The arrival of the tender was often a major event, breaking the monotony of isolation and bringing news from the mainland, mail from loved ones, and the opportunity for a brief respite from their solitary duties. The crews of these tenders, intimately familiar with the coastlines and the specific needs of each lighthouse, played an unsung but vital role in maintaining the entire lighthouse network. The architectural features designed to protect lighthouses from the elements, such as robust foundations, thick walls, and specialized storm windows, highlight the constant battle against the destructive power of the sea. Foundations were often sunk deep into bedrock or constructed with massive interlocking stones to prevent undermining by waves, while walls were designed to withstand the immense pressures of storm surges and battering winds. The lantern rooms, housing the precious lens, were typically enclosed with thick, reinforced glass panes, sometimes curved to deflect wave impact, and equipped with storm shutters that could be closed during the most severe weather. These structural considerations were paramount in ensuring the longevity and operational integrity of lighthouses, allowing them to stand firm against the most ferocious storms and continue their vital work of guiding ships. The meticulous record-keeping maintained by lighthouse keepers, including logbooks detailing weather conditions, vessel sightings, and any unusual events, provides invaluable historical data for maritime historians and researchers. These detailed logs offer a unique glimpse into daily life at a lighthouse, the challenges faced by keepers, and the ever-changing conditions of the sea, often containing personal observations and anecdotes that bring the past to life. The logbooks serve not only as operational records, but also as a form of communication between keepers, ensuring continuity of information and providing a historical narrative of the lighthouse's service. These handwritten accounts, often spanning decades, represent a rich repository of information about maritime traffic, coastal weather, and the human experience of living in isolation. The international cooperation in standardizing maritime signals, including light characteristics and buoyage systems, has been crucial for global navigation, ensuring that mariners worldwide can interpret navigational aids consistently. Organizations like the International Association of Lighthouse Authorities, IALA, have played a pivotal role in establishing common standards for lighthouse signals, colors of buoys, and other aids to navigation, thereby enhancing safety for international shipping. This standardization allows a mariner from any country to understand the meaning of a flashing light or a colored buoy, regardless of where they are in the world, fostering a universal language of maritime safety. The collaborative efforts of these international bodies underscore the global importance of lighthouses and the shared responsibility for ensuring safe passage across the world's oceans. The continued fascination with lighthouses, their iconic silhouettes against dramatic seascapes, and the romanticism surrounding their solitary existence ensures their place as cherished symbols of hope and resilience for generations to come. Beyond the international agreements that standardize their signals, the very architecture of lighthouses tells a compelling story of human ingenuity battling the relentless forces of nature, with each structure representing a unique engineering challenge overcome by dedicated builders and innovative designs. Early lighthouses, often simple bonfires on headlands or elevated platforms, gradually evolved into more sophisticated stone towers, their construction techniques advancing significantly from the Roman Pharos of Alexandria, which stood as one of the 7 wonders of the ancient world, to the medieval towers like the Tower of Hercules in Spain, continuously operational since the 2nd century AD. The transition from open flames to enclosed lanterns marked a pivotal moment in lighthouse technology, as glass panes protected the light source from wind and rain, allowing for a more consistent and reliable illumination that greatly enhanced maritime safety. The development of superior light sources became a constant pursuit, moving from wood and coal fires, which produced inconsistent and often smoky light, to candles, then to oil lamps, and eventually to the brilliant electric arc lamps and incandescent bulbs that power modern lighthouses. Whale oil, particularly spermaceti oil, was a preferred fuel for many decades due to its clean burning properties and bright flame, necessitating a robust whaling industry to supply the vast quantities required for thousands of lighthouses worldwide. The invention of the argand lamp in the late 18th century, featuring a circular wick and a central air draft, dramatically increased the intensity of oil-based lights, making them significantly more visible from greater distances and revolutionizing lighthouse illumination. However, a powerful light source alone was not sufficient. The light needed to be focused and magnified to be truly effective, leading to the revolutionary invention of the Fresnel lens by French physicist Augustin Jean Fresnel in the early 19th century. This ingenious optical device, composed of concentric rings of prisms and lenses, could concentrate a small light source into a powerful parallel beam, increasing its effective range by many multiples compared to traditional parabolic reflectors. The Fresnel lens came in various orders, with the largest first-order lenses often standing several meters tall and weighing tons, capable of projecting light for dozens of miles, becoming the iconic centerpiece of grand lighthouses around the globe. These magnificent lenses, meticulously crafted from polished glass, rotated on a bed of mercury or ball bearings, creating the distinct flashing or occulting patterns that allowed mariners to identify specific lighthouses and determine their position. The construction of lighthouses in particularly treacherous locations, such as isolated rock outcrops far offshore, presented extraordinary engineering feats. With structures like the Eddystone Lighthouse off the coast of Cornwall, England, undergoing multiple rebuilds as successive designs succumbed to the ferocious power of Atlantic storms. John Smeaton's third Eddystone Lighthouse, completed in 1759, was a pioneering achievement, utilizing interlocking dovetailed stone blocks and a tapered profile to resist wave forces, a design principle that influenced lighthouse construction for centuries. Similarly, the construction of the Bell Rock Lighthouse off the east coast of Scotland, completed in 1811 by Robert Stevenson, involved overcoming immense logistical challenges in a highly exposed location, with workers living on the rock for extended periods during construction, enduring extreme weather and dangerous tides. These formidable structures required not only advanced engineering, but also immense human perseverance and courage, as builders risked their lives daily to establish these vital navigational aids. The daily life of a lighthouse keeper, often romanticized, was one of profound isolation, relentless routine, and immense responsibility, as they were the sole guardians of the light, ensuring its continuous operation through all conditions. Keepers meticulously cleaned and polished the intricate Fresnel lenses, trimmed lamp wicks, refilled oil reservoirs, and wound the clockwork mechanisms that rotated the lenses, a demanding schedule that left little room for error. Their duties extended to maintaining the entire station, including the light tower, living quarters, fog signals, and often a boat landing, requiring a broad range of practical skills and an unwavering dedication to their charge. The solitude could be intense, especially at remote offshore stations, leading to a unique camaraderie among keepers when they did interact, and often a deep connection to the sea and the rhythm of the waves. Fog, the bane of mariners, necessitated the development of audible signals to complement the visual light, leading to the evolution of foghorns, bells, and sirens, each designed to penetrate the dense mist and warn ships of impending danger. Early fog signals included cannons fired at regular intervals or large bells rung manually, but these were often unreliable or lacked sufficient range, prompting the invention of more powerful steam-powered and later compressed air sirens, which produced distinctive blasts that could travel for miles. Each fog signal, like the light characteristic, had a unique pattern of blasts, allowing mariners to distinguish one station from another, even when visibility was zero, further enhancing the intricate system of maritime safety. The automation of lighthouses, beginning in the mid-20th century, gradually phased out the need for human keepers, as electric lights, reliable power sources, and remote monitoring systems could operate the stations with minimal intervention. This technological advancement, while increasing efficiency and reducing operational costs, brought an end to an era of dedicated human stewardship, transforming these iconic structures from bustling homes and workplaces into silent, automated sentinels. Many lighthouses now utilize modern LED light sources, which are highly energy efficient and require even less maintenance, further extending their operational autonomy and ensuring their continued role in the global navigation system. Despite the rise of satellite navigation systems like GPS, which provide precise positioning information to vessels, lighthouses retain their vital importance as visual aids, offering a reassuring confirmation of position and a crucial backup system in the event of electronic failures. Their enduring presence along coastlines and at hazardous shoals serves as a constant reminder of the physical relationship between land and sea, anchoring the human spirit in a world that is always shifting and changing, guiding mariners with a timeless beacon that transcends technological trends. The preservation of historic lighthouses, often undertaken by volunteer groups and heritage organizations, ensures that these magnificent structures, with their rich history and architectural grandeur, continue to stand as monuments to human ingenuity, resilience, and the enduring quest for safe passage across the world's vast and often unforgiving oceans.